Hey guys, tonight we slip into one of the strangest, quietest questions you can ask yourself when a room is dark and the world has finally stopped yelling at you for a second. What does time actually feel like from the inside? And does the universe itself care what your clock says? Maybe you're lying on your back, phone face down for once, ceiling just a vague blur above you. Maybe there's a street light sneaking past the curtains, or a sliver of moonlight on the wall, or absolutely nothing at all. Your body knows it's late. Your brain, however, is still loading 20 tabs at once. Before we let it slow down, I have one tiny favor. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you feel like sharing, drop a comment with where you're listening from and what local time your clock is insisting it is right now. It's always wild seeing all of our tiny nows scattered across the planet. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You can notice your own time without even looking at a clock. Just feel your body, the way your breath has its own slow rhythm, the way thoughts are still a little sharp from the day, like they haven't quite agreed it's bedtime yet. There's the clock time on your phone, and then there's this softer thing, the one in your chest and behind your eyes. Call it your personal now. It doesn't tick. It doesn't flash numbers. It just feels like the place you are. Sometimes that place feels stretched, like when you're lying awake, waiting for morning, sure that the night will never end. Sometimes it snaps past so quickly you only notice it when you realize the day is gone and you never really arrived in it. You've had both kinds of days. The long ones that drag, and the ones where you glance up and somehow it's already midnight and you're still in the same t-shirt you woke up in. Same 24 hours. Completely different experience. That's the first weird thing about time. We talk about it like it's one thing. We say, I don't have time, or I've got time, as if there's this neat little fuel tank somewhere that goes up and down. But there's at least two versions living in your life all the time. There's the external one. Minutes, appointments, alarms, deadlines. The part that decides whether you miss your train or pay your bills on time. And then there's the internal one. The way a 5-minute wait in a queue can feel like half an hour, and a 5-minute scroll on your phone somehow deletes 45 actual minutes from the universe. You don't need a physics degree to notice that those two times don't match. Your calendar says, you were alive all day. Your brain says, I was barely here for any of it. Or the opposite, your calendar shows 2 meetings and a grocery run, and your brain is like, we aged 6 years today. That gap between clock time and live time is where tonight's question starts to open. Because if even you in your own nervous system can't agree on what time is, what hope does the rest of the universe have? You can feel that question, can't you? You lying there in your own very specific now, in your own room, in your own corner of the planet, with the exact collection of memories and worries you're carrying tonight. This is your moment. It has a texture. It has a mood. Maybe it feels heavy. Maybe it feels fine. Maybe it feels oddly empty, like the calm after a storm. Whatever it is, it's real. Your now is real for you. But somewhere else, in another room, someone else is in a completely different now. Maybe they're making coffee. Maybe they're on a bus. Maybe they're staring at a supermarket shelf, totally overwhelmed by brand options at 11 p.m. Their heart rate, their thoughts, the meaning of this moment to them, completely different from yours. And yet, if you and that stranger could talk, you'd probably both say, yeah, this is happening right now. Now is such a bossy word. It acts like it owns the entire universe. This is what's happening now, but it's doing all of that with absolutely no evidence. You only ever have access to your own patch of reality, inside your own skull, plus whatever light and sound happens to reach you. The rest is your brain doing its best to guess. This is where we start poking at the big question without scaring your brain so much it refuses to sleep. Does the universe actually know what time it is? Or is that a weird human problem we invented because we hate being late? Think about the last time you checked the time without actually needing it. You just tapped your phone, glanced at the lock screen, and put it down again. It wasn't about catching a bus. It was like you were asking the universe for an update. So where are we? How far through this day are we? How guilty should I feel for not doing more? That little number glowing at you, 11:07 p.m. or 2:13 a.m. or whatever it was, felt like a verdict. But the phone isn't telling you what time it is in any deep sense. It's just showing you how many seconds have passed since we all agreed to call a particular moment, midnight on January 1st, 1970, or some other arbitrary starting point. It's a counting device, not a cosmic truth machine. The real thing you care about isn't the number. It's what that number means for you. Am I late? Am I early? Do I have time to watch one more episode? Will I hate myself in the morning? So you have this purely human structure, clocks and calendars, and then you have this felt sense, your tiredness or energy, your sense of rushing or dragging. And both of them are trying to answer the same question. What kind of moment is this? Now stretch that outwards. Outside your walls, the street is sitting in its own version of now. Some windows are dark, some are lit, some blue from screens, some warm and yellow. Cars go past every so often. Somewhere a dog is convinced it's their sacred duty to bark at absolutely nothing. That whole scene has its own tempo. Zoom further. The city, the country, the side of the planet that's in sunlight right now, the side that's in darkness. Somewhere, dawn is just beginning. Somewhere, lunch breaks are happening. Somewhere, two teenagers are having the most important conversation of their lives under a street lamp that doesn't care either way. If we could somehow freeze everything and take a cosmic selfie of this exact instant, capturing every person, every planet, every particle, that would feel like the universe is official now. But the universe doesn't actually do freeze frames. There is no giant pause button. There's no camera outside, everything looking in. There's just constant change everywhere all at once. So when you say, right now, I'm lying in bed, listening to some stranger talk about time, you're saying something absolutely true in your own little bubble. But outside your bubble, the phrase, right now, gets messy very quickly. Physicists have a rude way of describing this. At a deep level, nature doesn't care about your feeling of now. The equations don't have a special slot where they plug in present moment. Yes/no. They just describe how things change relative to each other. The universe cares about relationships. This particle moved here while that one did that. This star exploded after that cloud collapsed. It cares about order, not about a universal clock that tells everyone to move in sync. That's slightly offensive, honestly. You spend your whole life building your days around this feeling of this is happening now. And the universe is like, sure, if that helps you get to work on time. But before we get too annoyed at reality, it's worth sitting for a second with how weird your own experience already is. You never actually touch the present moment raw. Your brain is constantly running a little behind, taking in light, sound, sensation, doing a bunch of quick edits, and giving you a smoothed over version of what just happened and calling it now. It's like watching a live stream with a tiny delay. You don't notice it because your whole life has been that way. But under the hood, even your personal now is a best guess, not a direct line. So we've already got one layer of illusion. Your subjective present isn't as precise as it feels. Under that, we've got another layer. Your phone's time is just a convention agreed on by networks of machines comparing notes. Under that, there's the deeper layer we haven't really touched yet. What time means to the universe itself, the raw physics, when you strip away human schedules and sleepy brains. Somewhere between those layers, our question lives. You don't have to solve it. That's the nice thing about late-night questions. You're not writing an exam. You're just wandering with your thoughts a little, seeing what they bump into. It's like walking down a path in the dark with a small flashlight. You can't see the whole forest. You just see a few meters ahead, enough to keep going. Right now, your flashlight is on your own experience of time. The way this day has felt, the way this week has slid past or dragged, the way some memories feel like yesterday, and others feel like they belong to a completely different person. You can feel how slippery time already is before we even mention quantum anything. And that's the invitation. To notice that slipperiness, not as something wrong, but as a clue. If your sense of time is this stretchy, maybe time itself isn't the rigid, universal ticking thing we grew up imagining. Maybe the universe doesn't have a big central clock tower somewhere, bonging out the hours. Maybe it just has change. If that's true, then the devices we call clocks are doing something sneakier and simpler than telling you what time it is. They're just counting regular changes and pretending that count is a thing called time. Your watch doesn't know anything about your day. It just knows that a certain number of tiny, repeating movements have happened inside it. To really see that, we're going to have to walk right up to those clocks, pry open their faces, and ask them some very personal questions. Not yet. For the moment, it's enough to lie here, feel the weight of your own now, and realize that if even that isn't as solid as it seems, the universe's answer to what time is it might be stranger than anything your lock screen will ever show you. If you stare at the idea long enough, it starts to get unsettling. Your watch doesn't actually know what time it is. It just knows how many times something inside it has done the same little dance. Take the simplest one you can picture, an old-school wall clock with hands. Somewhere behind the face, there's a small world of gears and springs pretending to be organized. A spring unwinds, gears turn, a little escape will tick forward just one tooth at a time. Each tiny mechanical go is a repeatable change. The clock counts those, divides them into equal chunks, and then paints those chunks onto the world as seconds and minutes. That's all it's doing. Counting changes. Digital clocks aren't any more magical. They don't have gears, but they have something just as repetitive: electrical pulses. A crystal vibrates when voltage is applied. It wiggles back and forth at a very steady rate, like an outrageously fast metronome. The electronics divide those wiggles down like, okay, every N wiggles, we'll call that 1 second, and then they move the numbers on the display. No philosophy, no cosmic wisdom, just a crystal having a controlled little panic attack millions of times a second. Atomic clocks sound fancy, like they should be keeping time for alien civilizations or something, but they're doing the same trick with a different toy. Certain atoms absorb and emit light at very specific frequencies. That frequency is incredibly stable, so if you build a device that listens to those tiny transitions and tunes itself to them, you get a ridiculously accurate wiggle counter. Count enough of those, and you declare a second has passed. Gears turning, crystals vibrating, atoms flipping between energy levels. Underneath all the polished faces and glowing LEDs, clocks are just glorified change counters. Which raises the obvious, slightly annoying question. If what we call time is being measured by change, what happens in a place where nothing changes? Imagine a perfectly empty room. No air, no light, no sound, no dust, no phone buzzing on a table. Just a sealed box of nothing. You somehow float inside it, and we're going to ignore the awkward part where you still need to breathe. You're not moving. You're not thinking. No heart beating. No molecules bouncing around. No energy sloshing from one place to another. How would you tell if a second had passed? Or an hour? Or a year? You'd be in there, but without any change to mark before and after, those 3 words start to lose their meaning. They're like labels looking for shelves that don't exist. In physics, this isn't just a late-night stoner thought. It's a real problem. If time is the thing clocks measure, but clocks only measure change, then in a place where nothing changes, does it make sense to say that time passed? You can answer that in 2 ways. One answer is the stubborn, shrugging one. Yes, of course time still passes. Even if nothing is happening, the universe-wide clock, whatever that is still ticking. The fact that you can't tell is your problem. The other answer is the slightly more radical one. Maybe without change, time isn't doing anything. Maybe it's just a parameter in an equation with nothing to attach to. Out here in the messy real world, we never get the pure version of that empty room. Even in your bedroom at night, there's always something going on. Air molecules bouncing off your skin, neurons firing in your brain, the earth rotating, the moon drifting, the solar system cruising around the galaxy. You're swimming in changes whether you like it or not. So we get lazy. We start treating time like a substance, something that flows like water in a river or sand in an hourglass. It goes by. We lose it, or save it, or kill it. But underneath that language, physics is doing something different. It's not tracking how much time stuff has flowed through the universe. It's tracking how states change into other states. You don't need to remember any technical words, but the basic vibe is this. If you know how something is changing, you can use that as your clock. Your heartbeat could be a clock. Your steps on a walk could be a clock. The way a radioactive atom decays could be a clock. If you can say after this much change, I'll call that 1 unit, then congratulations, you've built a timekeeper. Which means, weirdly, that the flow of time is always tied to some pattern of change we've decided to care about. We picked the Earth's rotation first. 1 spin 1 day. Arbitrary, but convenient. Then we divided that spin into 24 hours for reasons that made sense to ancient people who really liked the number 12. Then we chopped hours into minutes and minutes into seconds. All arbitrary choices, but once everyone agrees on them, they become strong. Later we ditched spinning planets as our reference and said, okay, forget that, a second is going to be this many oscillations of this particular atom. We swapped one kind of change for another because the new one was more stable and didn't care about clouds or seasons. At no point did the universe hand us the official manual of true seconds and say, use this. We chose our clocks. We chose which changes to count. You can feel that in your everyday life more than you might think. When you cook something until it looks done, you're using a visual change as a clock. When you say, I'll just stay in for 3 more songs, you're using music as a clock. When a kid says, we'll go when this cartoon finishes, that cartoon's runtime has become a unit. And when you lie in bed, half listening to this, and you feel your body slowly exhale tension, you're using relaxation itself as a kind of time. There's a before, I was tight, wired, anxious. There's an after, I'm softer, looser, heavier on the mattress. The difference between those states is the shape of time for you tonight. This is why your internal time and your clock time never quite line up. Your nervous system isn't counting vibrations in a crystal. It's counting changes in you. How often your environment surprises you. How much novelty you're experiencing. How hard your attention has to work. Those are the ticks your brain cares about. Not seconds, but impacts. Sit in a waiting room with nothing to do, and your brain is forced to stare at the absence of change. Every tiny shift gets magnified. The squeak of a chair, the rustle of paper, someone's foot tapping. Your sense of duration inflates. 10 minutes feels like a year because every little change is being dragged out and examined. Scroll through something addictive, and the opposite happens. Your brain gets a fire hose of changes, images, jokes, tiny bits of drama, so fast and so constant that it stops marking them as separate events. It compresses. 70 changes get folded into one vague memory like, I was on my phone for a bit. Your internal clock shrugs and goes, that was what, 10 minutes? Meanwhile, your wall clock is like, sweetie, that was an hour. Both clocks are counting change. They just care about completely different kinds. Physics, in its most unromantic mood, would stand in the doorway and say, look, all I need is a way to parameterize change. I don't care if it's a pendulum, a cesium atom, or your Netflix autoplay. Give me something that repeats, and I can build a time coordinate. But hiding inside, that is a surprisingly gentle idea. Maybe time isn't a stuff the universe has. Maybe it's a way we describe the relationships between things that change. When we say it took the light 8 minutes to get from the sun to Earth, we're not talking about some invisible fluid that carried the light along. We're saying, given the speed of light and the distance, the pattern of change that links photon leaving the sun to photon hitting your face on the beach can be described with this number we call 8 minutes. If we stop counting, that link would still exist. The light would still travel. The pattern would still unfold. Our word, minutes, doesn't make it happen. It just labels it. That can be strangely freeing. You spend most of your life at the mercy of clocks you didn't choose. School bells, work shifts, deadlines. It can feel like time is something outside you, pushing you around. But at the deepest level, time is just the story of how things change. The universe isn't sitting there with a stopwatch, judging how long you spent on Instagram. It's just letting cause roll into effect. Of course, this is where the obvious objection pops up. If time is just change, why does change seem to have a direction? Why do we remember the past and not the future? Why does the coffee cool down and not heat itself up? That's a whole other door we'll walk through later when we talk about entropy and why broken cups don't leap back into your hand. For now, we're staying close to the clocks themselves. Gears, pulses, vibrations. They give us the illusion that time is a line stretched out somewhere, and we're sliding along it. But if all a clock ever does is say, "This many repeats of my little dance have happened," then there is no line out there. There's just a bunch of dances, each with its own rhythm. And the universe is full of rhythms. Electrons orbiting, hearts beating, planets spinning, waves crashing, people typing, your lungs rising and falling. Every one of these could be used as a time standard by some hypothetical creature who decided that was the change worth counting. Ants might run their lives on how many trips they can make between the nest and the food before the temperature drops. A tree might measure in growing seasons. We picked seconds, minutes, hours. The scales we use are human, but the underlying idea, time is counted change, is not. So when you next glance at a clock and feel that tiny stab of, oh no, it's already that time, you can reframe it just a little. You're not looking at a judge. You're looking at a box of gears or a chunk of silicon or a cloud of atoms calmly saying, while you were doing whatever you were doing, I have completed this many cycles of my own little behavior. That's it. No shame. No disappointment. Just two different systems reporting on how much they've changed. You live a certain number of heartbeats. The clock lived a certain number of ticks. If they don't match how you hoped, that's not a failure of time. It's just a mismatch of stories. And somewhere far beyond your room, other clocks you'll never see are also quietly counting. Pulsars spinning in space. Radioactive elements deep in rocks. Light bouncing between distant mirrors in some lab. None of them know they're clocks. They're just doing what they do. We're the ones who come along later and say, this change is reliable. Let's call that a second. We're going to take those different stories soon. Your story, your watch's story, the universe's story, and see what happens when they disagree in more dramatic ways. Clocks on planes. Clocks on mountains. Clocks near black holes. For now, just let the simple idea linger. Every time you ask, what time is it? You're really asking, how much change has happened for me, for my devices, for my day, and which one of those am I going to treat as the real one? You lying there right now, breathing a little slower than you were at the start of this, are already a slightly different you. A few billion atoms have traded places. A few old thoughts have loosened their grip. A few new ones have wandered in. Somewhere inside you, your own quiet clock, built from change, is still counting. And outside you, somewhere on your bedside table or across the room, another clock is counting something else. Neither one owns the truth. They're both just telling you their version of how this night is unfolding. So here you are, two clocks quietly counting the night. The one in your body and the one glowing somewhere nearby. Both of them claim to be telling you how this moment is unfolding, and they already disagree. You've seen how they fall apart in the most ordinary places. Think about being a kid in school, watching the second hand on the classroom clock crawl around the circle. You could swear you saw it hesitate, like it was taunting you. That last 5 minutes before the bell felt longer than the entire lunch break that came before it. Same clock, same number of seconds, completely different universe inside your head. Fast forward to now. There's a version of that feeling in adulthood. Waiting for test results. Sitting in traffic when you're already late. Watching the 3 dots typing in a chat box from someone whose reply suddenly matters way too much. The clock on the wall is minding its own business, ticking along steadier than your heartbeat. And somehow time has become this thick syrup that you're trying to walk through. Then there are the opposite days. You blink and it's gone. You sit down just to check something quickly, and then your stomach reminds you you've skipped lunch. Your messages are quietly accusing, and the afternoon has evaporated. Your calendar says, look, you had 8 hours. Your body says, no, I didn't. I had maybe 1.5 tops. That's the mismatch. The external time, the official schedule one, and the internal time, the felt one. Inside your brain, there's no little wristwatch tick-tocking away. There are messy, overlapping systems that all sort of approximate time from different angles. Some of them are tracking very short moments, like the gap between a sound and your reaction. Others are feeling out longer stretches, hunger cycles, sleep cycles, the rise and fall of hormones. Your sense of duration is stitched together from all of this. It's not a single instrument. It's a band improvising. When nothing much is happening and you're focused on the future, waiting room, loading bar, last hour of the workday, that band leans on prediction. Your mind keeps jumping ahead. Are we there yet? Are we there yet? Every time it does, it makes an empty comparison between where you want to be and where you still are, and that empty comparison feels like extra time. You're not measuring seconds. You're measuring impatience. When you're deeply engaged in something, a good conversation, a game, even a really satisfying round of cleaning where you suddenly become the main character in a mild home makeover montage, you stop making those empty comparisons. You're not checking where you are in the day. You're just inside what you're doing. The brain has less reason to ask, how long has it been? So when you finally look up, there's a tiny shock. The wall clock story is longer than the one you've been telling yourself. Emotions bend your time even further. Anxiety takes a moment and zooms in. Your internal lens punches in so close that you can see every little twitch of the second hand. Fear does something similar. People in accidents often report that everything slowed down. It didn't, of course. What changed was how densely memory was being written. Your brain started recording more detail per real-world second. And when you play that back, you experience it as stretched time. Calm does the opposite. When you're relaxed, your brain is stingy with detail. It doesn't bother to mark every tiny event. You get a sparse recording. Later, that sparse memory feels short, even if the actual clock time was long. An hour staring at the sea can feel like no time at all while it's happening and like a whole separate life when you look back on it. That's another twist. The way time feels while you're inside, it is not the same as how it feels when you remember it. While you're living a moment, your sense of duration depends on how much you're checking the time, how much your body is complaining, how wound up your thoughts are. Later, your sense of how long it was depends mostly on how much happened, how many distinct little chapters your memory can find. A holiday, for example, might go by in a blur while you're actually there, especially if you're busy. But later it occupies a big chunk of your mental year, full of vivid moments. A week that felt fast when lived becomes large when remembered. Meanwhile, a month of identical workdays might feel endless while it's happening, but collapse into almost nothing in memory, because your brain just shrugs and files it as more of the same. Your internal clock is not one thing. It's a storyteller that edits time differently, depending on whether it's writing in the present tense or past tense. You can see why you and your alarm clock are never going to fully agree, even if they're both right in their own way. One is counting vibrations. The other is counting experiences. Tonight, as you lie there, that storyteller is doing its usual work. Maybe the day felt too short and you're annoyed at how little you got done. Maybe it felt too long and you're just grateful it's over. Either way, there's a quiet judgment baked into it. I used my time well, or I wasted my time. But from the point of view of the little device on your bedside table or the numbers at the top of your phone screen, none of that exists. There is no good hour or bad one. There are only cycles, pulses, repeats, a certain number of ticks between when you woke up and now. That gap between the neutral, mechanical count and the loaded, emotional story is huge, and you live in it constantly. You say things like time is dragging or I'm racing the clock, as if there's a race happening between you and some external force, but really you're racing your own expectations. When you wish you had more time, often what you mean is, I wish I felt less rushed, less scattered, less behind. If you could slow your inner narrative down, lower the pressure, the same number of seconds could feel completely different. And yet, under all that subjectivity, there's something that feels weirdly solid about time, too. You can't go back and fix this morning. You can't jump ahead and borrow tomorrow's afternoon. However elastic your perception is, it still flows forward. The mismatch between your time and the clock's time never goes so far that you genuinely walk out of the movie before you've walked into it. So there's this strange double life. On the surface, time is wildly flexible in your experience. Underneath, there are constraints that never break, only bend. You have tiny, everyday evidence of those constraints. If you've ever slept through an alarm, you've seen how your body insists on its own schedule, ignoring the artificial one. If you've ever been jet-lagged, you felt your internal time zones arguing with the local ones. You can tell your body, it's 9 a.m., we're at work now, and your body, still convinced you dragged it out of bed at 3 a.m., will disagree loudly for days. Somewhere deeper, cells are sticking to cycles. Hormones rise and fall. Your temperature follows its own pattern. Your brain gives you waves of alertness and sleepiness that don't care what your calendar says. Now and then, you catch the conflict directly. You look at the time and feel disbelief. No way. It cannot be that late. Part of you wants to argue with the numbers, as if they're trying to gaslight you. But the clock is just reporting its slow, steady change count. It doesn't know you were in a flow state, or doom scrolling, or napping. Sometimes it goes the other way. You check the time, and it's earlier than you thought. There's a little gift of extra minutes. Nothing actually changed, but the story you were telling about your day gets a small edit, and you feel lighter. This tug-of-war between felt time and measured time might seem like a purely human quirk, just another one of those brains or weird matters. But this is exactly where physics starts to quietly tap you on the shoulder and say, by the way, you're onto something. Because, annoyingly enough, on the big scale, time really isn't the same for everyone. This isn't just about moods and boredom. The closer we look, the more the universe itself behaves like that disagreeable friend who refuses to show up to dinner at the same time as everyone else because they're on their own schedule. We're not there yet. For the moment, it's enough to notice that even before we involve rockets and black holes, you live with a kind of personal time that's only loosely connected to the thing we pretend is universal. You can lie here and remember 3 different days. One that flew by, one that dragged, one that felt exactly the right length. The planet spun once during each of them. Your watch added the same number of seconds to its internal count, but the way they live in you is utterly different. That alone is enough to make the question, what time is it, suspicious. Because whenever you ask it, the honest answer is always split in 2. There's the short, neat, digital answer. It's 11:42 p.m. And there's the slower, messy A1. It's the kind of moment where I feel like this, with this much energy, this much regret, this much relief, this much hope. The first one is easy to read aloud. The second one only shows up if you sit quietly with yourself for a second and listen. Right now, somewhere inside your chest, that second answer is forming, even if you haven't put it into words. You know what kind of night this is. You know roughly how heavy your limbs feel, how loud your thoughts are, how much weight the day left on your shoulders. In a few hours, your alarm will pick a number and shout it at you. That's one kind of time. This moment, now, we are letting your attention soften while you hang out with a big cosmic question. That's another kind of time entirely. And the strange thing is, both of them matter when we start thinking about the universe. Because the universe doesn't just contain atoms and galaxies. It contains you experiencing all of this from the inside. Any answer to does the universe know what time it is has to make room for both, the mechanical ticks and the human ones. Soon, we'll zoom out and see what happens when different clocks, the kind strapped to satellites and rockets, stop agreeing with each other in measurable, physical ways, not just emotional ones. For now, you can just lie there between your 2 clocks, feeling that quiet tension, and realize that the simplest, most innocent question you ask your phone every day already has more than one answer. By now, you've got this quiet feeling that time is already a bit slippery just inside your own life. The uncomfortable part is that the universe agrees with you. It's not just that your brain and the wall clock can't sync up. The universe itself refuses to keep one single, clean schedule. We're going to blame a man with a mustache. You've seen him a million times in thumbnails and documentaries. Einstein, with that I haven't slept since 1903 hair. His big insight wasn't just E equals mc squared. It was something much subtler and more annoying. The idea that even the universe's most basic measurements are not the same for everyone. People had already noticed something odd about light. No matter how fast you run toward it or away from it, it always greets you at the same speed. That's not how anything else works. If you jog into a breeze, you feel more wind. If you drive toward a car, it reaches you faster. But light? Light refuses to play along. It acts like it has one speed limit and it doesn't care what you're doing. Einstein took that weird little fact seriously and asked, okay, what if we stop trying to change the speed of light and instead accept it as fixed? What would have to give way instead? The answer, annoyingly, was time and space. Both. Imagine, just for a second, that you're on a very smooth train moving at a constant speed. Inside the train, someone does a little experiment. They shine a flashlight straight up to a mirror on the ceiling and back down again. To them, the beam goes straight up and down like a neat little triangle, floor, mirror, floor. Now picture yourself standing on the platform watching that same train go past. You see the light too, but from your point of view, it doesn't go straight up and down. While it's traveling, the train is sliding along the tracks, so the light traces a diagonal path, forward and up, then forward and down. A longer route than the person on the train sees. Here's the catch. The speed of light has to be the same for both of you. You both agree on how fast it moves, but you don't agree on the path it takes. If you both insist that nothing funky is happening to the light, then something funky must be happening to your measurement of how long it takes. That's the heart of Einstein's special relativity. If the speed of light is fixed and space looks different to people moving at different speeds, then time must look different too. For the person on the train, maybe the light's trip took 1 second. For you on the platform, watching it travel a longer diagonal path at the same speed, it has to take a bit more time. You both think you're right, and somehow you are. This isn't about one of you having a broken watch. It's that the universe doesn't give everyone the same grid to measure time and space on. Your grid depends on how you're moving. You can feel how wrong that sounds. Time is supposed to be universal. A second is a second, right? But once you start allowing different observers to move differently, the universe stops caring about that. It cares about something deeper, the combined structure of space and time together. That's where space-time comes in. If space and time kept changing separately for each observer, physics would fall apart. You'd never agree on anything. But if you merge them into one four-dimensional thing, 3 directions of space, 1 of time, suddenly the rules become simple again. You're not arguing about separate space and separate time anymore. You're agreeing on the geometry of space-time as a whole. You don't have to picture 4 dimensions to get the idea. Just imagine a map. On a flat map of a city, you have left, right, and up, down. If 2 people draw their maps with different orientations, one with north at the top, one with east at the top, they'll use different x and y coordinates, but the distance between any 2 points stays the same. The underlying geometry doesn't change. Space-time is like that, but with time rolled in as an extra direction. Different people, moving differently, slice that 4-dimensional block in different ways. They disagree about distances and durations, but they agree on the deeper structure. For someone zipping past you in a spaceship, your now slice and theirs are tilted. What you consider simultaneous events might not be simultaneous for them. 2 fireflies blinking at the same time in your sky could be slightly out of sync in theirs. It's not just that their watch is off. The idea of at the same time simply isn't universal anymore. So already, before we even talk about gravity, the universe has quietly killed the idea of a single cosmic time. There is no master clock that everyone can sync to. There are only local times, each depending on how you're moving. Einstein called the time you personally measure along your own path your proper time. It's what your own wristwatch would record if it stays with you. That proper time is completely valid, completely real, and completely yours. But it won't match someone else's proper time if their path through space-time is different. This is where the twin story comes from. One twin stays on Earth. The other zooms off on a very fast spaceship, turns around, and comes back. When they reunite, they disagree on how much time has gone by for each of them. The traveling twin has experienced less proper time. They are physically a bit younger. It sounds like sci-fi, but it falls straight out of this geometry. Moving quickly through space changes how you move through time. The faster your speed, the slower your clock runs compared to someone at rest. You're trading some of your travel budget in the time direction for travel in the space directions. Now gravity steps into the picture and makes everything even weirder. We used to thinking of gravity as a force that pulls down. You drop your keys, the Earth tugs on them, the end. Einstein stepped back and said, what if that pull is really just a side effect of curved space-time? Picture a stretch sheet with a heavy ball sitting in the middle. The fabric dips, roll a marble near it, and the marble's path curves, not because the ball is literally pulling sideways on the marble, but because the marble is following the straightest path it can on a curved surface. That trampoline picture gets overused, and it's not perfect, but it does give you a feel for the idea. Mass and energy distort space-time. The straight lines through that distorted landscape look curved to us, and we call that curvature gravity. If space is bent around massive objects, time gets bent with it, because they're part of the same fabric. You can't curve one without affecting the other. Down here at the surface of the Earth, you are sitting in a little dent in space-time. The dent is not dramatic, it's subtle. But it's enough that objects near Earth feel a pull toward the center. It's also enough that time, as measured by clocks closer to Earth's center, runs just a tiny bit slower than time measured farther away. That means if you took two perfect clocks, put one at sea level and one on top of a mountain, waited a while, and then brought them back together, they would disagree. The one higher up in the weaker gravity would have ticked ahead. There's a sort of poetic justice to that. People who live at higher altitude are very slightly older than the rest of us. Your head is slightly older than your feet. It's a stupidly small difference in daily life, but it's real. Where special relativity says move fast and time slows, general relativity adds sit deep in a gravitational well and time slows too. Motion and gravity are two sides of the same geometric story. If you imagine space-time again as a kind of landscape, proper time is like the length of the path you walk along that landscape. Two people can start and end at the same points but take different routes, one looping around, one going straight, and end up having walked different distances. In space-time, those different routes give different amounts of elapsed time. A clock on the International Space Station follows a slightly different route through space-time than your clock on the ground. It's higher up, so the gravity there is weaker, which should make it tick faster. But it's also moving very fast around the Earth, which should make it tick slower. Both effects are real. You have to add them up to see who ages more over in orbit. Behind all these calculations is a very simple, very humbling message. There's no single, objective answer to how much time has passed between these two events, without also saying for whom. It's wonderfully rude. The universe keeps forcing you to add that second part of the sentence. No more lazy, it took 1 hour. You have to say, it took 1 hour for this particular observer on this particular path, in this particular gravitational field. You're already living with your own scaled-down version of that rudeness. Your emotional state, attention, and memory all reshape your personal timeline. Einstein's work says the universe does the same kind of thing physically with motion and gravity. Your late train and your stressed-out brain make 10 minutes feel like an eternity. The universe, meanwhile, quietly stretches and squeezes those same 10 minutes depending on how fast you're going and how deep you're sitting in a gravity well. Tonight, Lying still, you're not moving anywhere near fast enough to feel the special relativity part. The speeds where that matters are close to light, and you are, mercifully, not a photon. But the gravitational part is happening right now. The floor under you, the ground below that, the Earth's mass all the way down to the core, are shaping the curve of space-time you're resting in. Your clock, your literal one and your biological one, are both ticking at a rate that depends on that curve. Someone floating far out in deep space, far from planets and stars, would have their own rate. If you could somehow sync up, compare watches, and then drift apart, you'd both be moving through time at slightly different tempos, even if you both felt normal. That's the odd comfort in a way. No matter how bent or stretched your time gets relative to someone else's, your own proper time always feels perfectly ordinary from the inside. The astronaut doesn't feel time slowing down. The satellite doesn't feel offbeat. They just live their seconds, one after another, unaware that some distant observer's bookkeeping disagrees. You have that same experience on all the smaller scales we talked about. You never feel your own now as distorted. It's only when you compare it to a clock, to another person's story, that the mismatch shows up. Einstein's gift, or curse, depending on your mood, was to show that those mismatches aren't just psychological. They're baked into the geometry of reality. Time isn't a single river we're all drifting down at the same speed. It's more like a network of streams winding through a landscape that's constantly curving under the influence of mass and motion. Where you are, how fast you're moving, how much gravity is tugging on you, all decide how your stream flows. Soon, we'll stop imagining and look at the very real ways we've had to adjust our technology, planes, skyscrapers, satellites, to cope with this bendy time. But for now, as you lie still in your own slight dent in space-time, you can let a strange thought settle in. Even if you never leave your room, your time is not the universe's time. It's your path through a curved, shifting fabric, measured by your own little clock, ticking at its own perfectly ordinary, subtly unique pace. Once you hear that time bends with motion and gravity, it's tempting to think, okay, cool theory, but down here on Earth I still have a clock in at 9 a.m., so how much does it really matter? It sounds like one of those ideas that only shows up near black holes or in sci-fi movies where everyone is inexplicably attractive and bad at seatbelts. But the universe is more stubborn than that. It sneaks its weirdness into ordinary places. Airplanes, tall buildings, the phone in your hand trying to figure out where you are. Imagine you and I each have a really good clock. Not a cheap wall clock that loses a minute every couple of weeks, but something precise, an atomic clock you'd normally only see in a lab. We sync them carefully, put them side by side, and make sure they agree down to the tiniest fraction of a second. Then we split them up. You keep one at home on a nice stable shelf. The other one we treat less kindly. We put on an airplane. The plane takes off, circles the globe a few times, flying east and west to high altitude, then lands. We take the traveling clock, bring it back to your room, put it right next to the one that stayed, and compare. If the universe were running on the simple, rigid time we grew up with, both clocks should still match. They've both been ticking this whole time. They're both perfect. No one dropped them, hopefully. But when physicists actually did this in the 1970s, the clocks did not match. The one that flew experienced time slightly differently. It ticked fewer ticks than the clock that stayed home. It aged less. There was no mistake, no broken device. This was Einstein's annoying geometry turning up on your boarding pass. Up in the plane, the clock was moving fast relative to the ground. Special relativity says, move fast, lose time. At the same time, though, it was higher in Earth's gravitational field, where gravity is a bit weaker. General relativity says, weaker gravity, gain time. So the poor clock was trapped in a tug-of-war. Motion was trying to slow it down. Altitude was trying to speed it up. Do the math, balance the two effects, and you get a very precise prediction for how far out of sync it should be when it comes back. When the experimenters compared the clocks, that's exactly what they saw. The universe had followed its own weird rules perfectly. You might never notice this with a normal wristwatch. The differences are tiny. We're talking billionths of a second over long flights. But they're big enough that with good instruments and patience, you can measure them. Time on the plane really did pass differently than time near your floor. The same thing happens in tall buildings in a quieter way. Take two identical atomic clocks. Put one in the lobby. Put the other on the top floor. Leave them for a while. When you compare them, the one up high will be slightly ahead. The reason is pure gravity. The higher clock is farther from Earth's center, where the gravitational dent in space-time is a bit shallower. General relativity says clocks tick a bit faster there. No one feels this in their day-to-day. Nobody moves into the penthouse to age more dramatically. But from the point of view of physics, the people on the top floor are very slightly older than the people at reception. Your own body is doing a miniature version of this. Your head, being farther from the Earth's center than your feet, is aging just a tiny bit faster. Over your whole life, the difference amounts to, well, practically nothing, but it's there. If you want to be extremely dramatic about it, the you that notices your toes is already different in age than the toes being noticed. You never feel this because you don't have another version of yourself in a different gravitational field to compare to. But the clocks we build do. And when they don't agree, we can't just shrug and say, oh well. Sometimes the disagreement matters. Look at the little glowing map on your phone when you're trying to find a cafe or a train station. Behind that clean blue dot is an entire swarm of satellites orbiting the Earth, each carrying a precise atomic clock. They're also zipping along at several kilometers per second and are high above the surface in weaker gravity. So each of those satellite clocks is experiencing two relativistic effects at once. Special relativity from their speed, general relativity from their altitude. Both effects are small, but small gets dangerous when you start stacking it up over distance. If we ignore relativity and just pretended time was the same in orbit and on the ground, the satellites would drift. Their internal times would slowly slide away from Earth's clocks. The signals they send out, hey, it's this time for me, and I'm here in my orbit, would arrive just a little bit wrong. To work out where you are, your phone basically listens to several satellites at once and measures how long their signals took to reach you. Multiply that travel time by the speed of light, and you get distance. Do that with a few satellites, and your phone can triangulate your position. If the timestamps are off, those imagined distances are off. If the distances are off, your lovely blue dot ends up not where you actually are, but somewhere nearby. Nearby, in this case, means dozens of meters away after just a day. That would mean you are here on your map would quickly turn into you are in the river, or you are in the next street over, or you are mysteriously walking through the wall of your neighbor's apartment. So the engineers who designed the system did the uncomfortable, grown-up thing. They listened to Einstein. They calculated exactly how much slower the satellite clocks run because of their motion and how much faster they run because of their weaker gravity, and they built in corrections. Because of that, the clocks on the satellites are deliberately set to tick at a rate that looks wrong if you bring them down to Earth, but looks right when you're standing here, pointing your phone at the sky and asking, okay, where am I? Every time your phone locates you correctly enough to guide you one block to your destination instead of 5 blocks into a fountain, you're using general and special relativity. You're using bent time. Think about that for a second. The same physics that says a twin on a fast spaceship can come back younger is quietly keeping you from getting lost on your way to buy snacks. We do this correction dance in more places than you might think. High-precision experiments, like the ones that test whether fundamental constants really are constant, have to account for Earth's rotation, its orbit, the altitude of the lab, and those tiny relativistic differences. If you care about measured time at the level of nanoseconds, you can't pretend time is simple anymore. The bends start to show, and once you know that these bends are real, it becomes hard not to see them everywhere, even if they're completely invisible in everyday life. An airplane isn't just crossing countries. It's carving a slightly different path through space-time than you are in your bed. A satellite isn't just circling the planet. It's living in a region where gravity and speed conspire to shape its sense of duration differently than yours. Even just standing up changes your relationship to time microscopically. You move some of your body higher in the gravitational field. You step into a slightly different tempo. None of this means we have to panic and reschedule our lives because of time holes or something. On human scales, the effects are tiny. But the fact that they're measurable and that our technology depends on acknowledging them tells you something important. Time is not a single, flat thing stretched evenly across the universe, or even across the room. Every clock has its own truth, rooted in its path and its environment. Move the clock, change the truth. You've already felt a softer version of that with your emotional time. Different days, different moods, different memories, all giving you different lengths of a day, even while the official count stays the same. Relativity just adds a physical layer to that. Different motions, different gravities, different altitudes give you literally different amounts of time between the same two events. It's easy to shrug and say, okay, fine, time is slightly bendy, I'll try to cope. But if you let it sink in, there's something strangely beautiful about it. The universe could have been dull and rigid. It could have been built with one single cosmic metronome ticking away, and everything would be forced to keep step with it. Instead, each path through the world has its own rhythm. The universe gives you your own proper time, your own personal tally of how much you've experienced between birth and whatever you're doing right now. Someone else can sit right next to you, breathe the same air, listen to the same video, and still have a slightly different tally, because their journey through the gravitational and motion landscape has been different. On Earth, those differences are microscopic, but they exist. Out in space, near massive objects, they get larger. Near something truly extreme, like a black hole, they become dramatic. All these tiny airplane experiments, skyscraper comparisons, and GPS corrections are like gentle warm-ups for the real high drama of time dilation. They prove that the ideas are right in our own backyard, so that when we imagine the stranger scenarios, we're not just indulging in fantasy. We're extrapolating from things we've already seen. Right now, you are lying still, probably not orbiting the Earth at several kilometers per second, probably not camped at the edge of a black hole. Your proper time is humming along in a pretty normal way. The clock on your phone is humming along in its own way. Somewhere overhead, a satellite clock is doing its thing a little differently. All of those little differences are quiet, harmless, almost gentle. But if we keep following them outward into stronger gravity and higher speeds, the differences stop being tiny. They become gut-level weird. They turn into things like an hour for you, decades for me. We're about to stand next to one of those places. We'll stay safe. You won't have to get out of bed. But mentally, we're going to walk right up to an object so heavy that it doesn't just curve space-time slightly. It digs a well so deep that time itself seems to pool and slow near the bottom. The airplane clocks and skyscraper clocks are whispering to you that this will be real. They're the soft echo of a louder message. If gravity can nudge time in a tall building, imagine what it does where gravity stops being polite. The little nudges in airplanes and skyscrapers are like the universe clearing its throat. If you really want to hear it speak, you have to go somewhere much more dramatic. So, for a moment, forget jet lag and GPS. We're going to stand beside a black hole. Don't worry, you're not actually getting up. You're still in your bed, same pillow, same room. This is a thought experiment, the safest kind of experiment you will ever do. The only thing at risk here is your sense of what later means. Start by picturing something heavy, a planet maybe, or our sun, big enough that you know you'd be crushed if you try to hug it. Now imagine taking that mass and slowly shrinking it, pressing it into a smaller and smaller volume without changing how much stuff is there. The gravity at the surface grows. The curve in space-time gets steeper and steeper because all that mass is being packed into a tighter knot. Keep compressing. At some point, there's a threshold where no matter what you do, the gravity of the surface is so fierce that even light, moving at its cosmic speed limit, can't escape. If light can't get out, nothing can. That's the point where you've made a black hole. Already, that's a pretty good mood for a bedtime story. An object so intense that it basically punches a hole in the concept of a way. But the thing we care about tonight isn't the pull. It's the way that pull deforms time. Because a black hole isn't just a strong gravity source. It's gravity turned up so high that the dent in space-time isn't a gentle bowl anymore. It's a well. A cliff. A place where the slope is so steep, try to stand still becomes more and more like leaning on a treadmill set to absurd. Let's make it a bit more concrete. Imagine a black hole sitting out in space, far away from everything else. Around it is a region where, at least in principle, you can still hover if you have a powerful enough engine. If you fire your thrusters just right, you can hang at a fixed distance, like a helicopter holding position, only without air and with way more math. We'll park you there, safely outside the point of no return, but close enough that the gravity is intense. You're in a sturdy ship with big engines and thick windows that somehow, conveniently, transmit Wi-Fi and existential dread. You look down, or whatever counts as down in this setting, at the black hole. You don't see a hole exactly. You see darkness, because light trying to escape from too close gets dragged back in. Around that darkness, you might see a bright, violent ring of matter spiraling in, heating up as it falls. Space itself near that edge is warped in ways your eyes have never had to interpret before. The whole scene looks wrong in a way that's hard to describe. Now you check your watch. Whatever you're using to tell time, some high-tech atomic device, or just a digital readout on the console, seems perfectly normal. A second passes, another. Your heart still beats, your thoughts still flow. If you didn't know where you were, nothing about your personal sense of time would feel strange. Meanwhile, far away, maybe back on Earth, your friend is also looking at a clock. Before this whole adventure, you synced your devices. Agonizingly careful, like those airplane experiments, only with more drama. You agreed. When we meet again, we'll compare and see how much time each of us has lived. From your point of view, near the black hole, you talk to them over a radio link. Their voice comes through just fine at first. You trade a few comments about how ridiculous this all is. You tell them what it looks like, this spherical patch of darkness with light smeared around it like paint being flung into orbit. But as you stay there, holding position in that steep gravity, well, a new kind of mismatch starts to grow. It's not just the emotional one anymore. It's not, this feels long, while the clock says it's short. The clocks themselves begin to disagree. According to the rules you've already seen in skyscrapers, the deeper you sit in a gravitational well, the slower your clock should tick relative to someone higher up. A black hole is the skyscraper turned up to 11. The basement level near its edge is so deep in the curve of space-time that the slowdown becomes dramatic. You might be there for, say, an hour by your own count. Your watch ticks through 3,600 seconds. You could drink a cup of coffee, make a few notes, stare into the abyss, reconsider your life choices, all at your usual pace. Your friend, watching from a safe distance, doesn't see that hour unfold the same way. From their perspective, every signal you send, every bit of light that escapes from your ship, has to climb out of that steep gravitational well. As it climbs, its frequency gets stretched. The light shifts to redder colors. The radio waves stretch, too. Your voice, if they could play it back unprocessed, would begin to sound slower and lower, like someone dragging their finger along a record. They would see your onboard clock tick more and more leisurely. Your hand gestures, if they had a video feed, would start to look like slow motion. As you hover closer to the edge, the event horizon, they would see you move as if you were wading through thick syrup. Not because you actually feel slowed down, but because their time and your time are being warped relative to each other by that extreme curvature. If you edged closer still, staying just outside the point of no return, this effect would grow. From far away, it would look like you were stretching your hour into something absurd. The light from your ship would get redder and fainter. Your clock would appear to tick slower and slower, asymptotically approaching a standstill as you flirted with the horizon. Somewhere around then, your friend would probably start yelling at you to please stop flirting with the horizon. Here's the part that makes people's brains itch. From your seat, right there in the gravity, your hour stays an hour. You don't feel your thoughts slowing. You don't feel your speech lengthening. You don't notice your watch fighting the black hole. As far as your own experience goes, time feels normal. It always does. That's the treacherous thing about proper time. From the inside, it never announces, by the way, we're going weird now. So we end up with two true statements that don't match. I spent 1 hour hovering near the black hole. Your friend, during that hour for you, I saw much more time pass for me. The universe, smugly, allows both to be right. If you eventually fire your engines, climb back out of the well, and make the long trip home, you can put those clocks side by side again. Just like the airplane clock, but with a lot more drama. Your friend might have aged years more than you. Depending on how close you went and how long you stayed, the difference could be staggering. Decades, in the more extreme science fiction-y versions. From the perspective of general relativity, nothing magical happened. You followed a path through curved space-time that gave you less proper time between departure and reunion than your friend's path did. You took a shortcut, in a sense, but in the time direction, not the space direction. From the perspective of your everyday intuition, though, this is absolute nonsense. This is the kind of thing that makes you want to take time itself into a quiet room and ask it what its problem is. We can push this thought experiment one step further into the place where descriptions start to feel like optical illusions. Instead of hovering near the black hole, imagine that you turn off your engines and let yourself fall. No fighting, no holding position. You just let gravity have you. From your perspective, it feels like falling toward any other massive object, at least for a while. You accelerate. You see the black hole grow in your viewport. You feel weightless because locally there's nothing pulling on you. Everything around you is falling at the same rate. If the black hole is big enough, the tidal force is the difference between how hard your head is pulled and how hard your feet are pulled, might be gentle enough that you don't get stretched painfully. Large black holes can be weirdly polite like that at their edges. You check your watch. Seconds tick by at their usual pace. You could hold a conversation, look at your hands, think, wow, I'm making questionable choices, all at normal speed. From very far away, though, your fall never quite finishes. Your friend, watching your descent, sees you approach the event horizon, the boundary beyond which not even light returns, and slow down. Not because you hit anything, but because the light carrying the story of your fall is being stretched and delayed. Each signal from you takes longer to climb out. Each one is more redshifted than the last. To them, your fall looks like a movie being played slower and slower. You, blissfully unaware of any of this, cross the horizon in some finite proper time. Your watch says, we're here. If there were a way to send that message back, it would never arrive. The horizon is not a place. It's a line in space-time that marks too late for outside communication. For you, time keeps going. For them, your final visible moment freezes, smeared out, and then fades as the light carrying it gets stretched into invisibility. There's a quiet, almost poetic cruelty in that. From the outside, it looks like time stops for you at the edge. From the inside, time stops for them as you fall. You lose contact with their future. They lose access to yours. No fancy metaphors required. That's just what happens when space-time is curved so sharply that different paths through it define wildly different nows. You can feel what this does to the idea of a universal present. There's no single what's happening right now at the black hole that everyone can agree on. For you hovering nearby, now might include your ship's control panel, the glow of the accretion disk, the soft hum of your engines. For your friend back home, now includes your image, lagging, slowed, distorted, and perhaps already faded beyond detection. And for someone else, living in another galaxy, looking through a telescope, now is something else again. Maybe they're seeing light that left this whole scene long before you were even born. Your bedtime brain might be tempted to throw up its hands at this point and say, "Okay, enough, this is too much." But quietly, underneath the mental chaos, something very simple is taking shape. The universe does not run on a single "what time is it?" There is only "what time is it for this observer on this path in this gravity?" You've been practicing that kind of relativity your whole life without realizing it. You've had days where your hour and someone else's hour didn't match emotionally. You felt like you spent a lifetime in a waiting room while they felt like they only kept you 10 minutes. You argued, but in your own ways, you were both right. Black holes just take that general subjectivity and crank it up until it becomes objective. It's not just feelings. It's the clocks themselves disagreeing. And if the clocks themselves disagree in that way, near a black hole, if your hour and someone else's year can be equally valid, then the question, does the universe know what time it is, starts to look different. Because what time would we even be asking about? The time on your watch as you hover above the horizon? The time on your friend's watch as they age back home? The time in the math that describes the whole space-time around the black hole, which includes both of you at once. The universe doesn't step in and break the tie. It doesn't announce a winning answer. It just lets each path have its own tally and make sure the tallies fit into the larger geometry without contradiction. You, still lying in your bed with no black hole in sight, are safely out of that extreme regime. But the rules that bend time, they're the same rules shaping your quiet little gravitational well here on Earth. They're the same rules whispering in the airplane clock, nudging the skyscraper clock, and keeping your GPS honest. In the gentlest possible way, they're also whispering in your ear, your time is yours. Not just emotionally, not just metaphorically, but physically. It's the measure of your particular journey through a universe where there is no master schedule, only a curved fabric and countless paths woven through it. The black hole is intense, dramatic, pure cinema. It's hard to imagine anything stranger than time pooling and slowing at the edge of an invisible cliff. But here's the twist. Most of the universe is not like that at all. It's not packed and blazing and violent. It's empty. Not cozy room empty. Not, oops, I haven't decorated yet empty. Empty in the literal sense. No air, almost no atoms, no sound, just distance and a darkness that isn't really black, just absent. And the weird thing is, time still has to mean something there. Let's drift away from the black hole, away from stars, away from anything dramatic. Let's put you in the middle of nowhere, between galaxies, where there's nothing but a few lonely particles per cubic meter and a background glow left over from the early universe, stretched into microwaves. You're still lying in your bed, obviously, but imagine a little version of you, or a probe, floating out there. No nearby planets, no bright suns. The sky is sparse and dim. If you spin, you won't feel it. There's nothing around to give you a sense of motion. What would time feel like there? The clocks we've been talking about, gears, crystals, atoms, satellites, need something to push against. They rely on change. Oscillations, pulses, decays. In interstellar space, there's no atmosphere to shake. No wind. No ticking on the wall. If you were just a conscious bubble in that emptiness with no physical processes, time would be impossible to sense. But the thing is, you're never just a conscious bubble. Even the tiniest piece of machinery can be a clock if something inside it is changing. If we send an actual probe into that emptiness with a precise clock on board, that clock will keep ticking. Its vibrations don't care how lonely the surroundings are. The only difference is that there's nothing external to compare to. From our point of view, back on Earth, we could listen to that probe's signals and say, okay, it's been out there for 10 years. The probe's clock and ours would disagree slightly because of relativity, different gravitational fields, different motions, but both of them would have a story to tell. Time doesn't vanish just because you're far away from things happening. It's baked into the structure of space-time. But this is where that earlier thought about change starts tugging at your sleeve again. If somehow a region of the universe became perfectly still, no particles moving, no fields fluctuating, no quantum jitters at all, What would time even mean there? You could still put t equals 5 minutes into an equation on paper, but physically, there'd be no way to tell the difference between t equals 5 and t equals 50. No before or after. Just same. The universe doesn't give us those perfectly still regions, though. Even in the darkest voids between galaxies, there's motion. There's light moving through. There are particles drifting. There's the thin, cold whisper of the cosmic microwave background. Ancient light stretching across billions of years just to politely smack into a detector on some satellite and tell us a story. That light is a built-in clock. Not because it's time for us, but because it has to travel. Light from a distant galaxy that hits your eye tonight has been crossing empty space longer than your species has existed. Its journey is a measure of time, whether anyone's watching or not. When you look up at the night sky, even from a light-polluted city, even just catching a handful of stars, you're literally looking into the past. Not metaphorically, not poetically, but straight up physically. The farther the star or galaxy, the older the light. There is no live feed in the universe. Everything you see is late. That means when you say, right now, that star looks like this, what you really mean is, right now, my eyes are receiving photons that left that star a long time ago. Your now is already crisscrossed with other people's thens. The universe is a patchwork of delayed signals. Your present is full of other places' history. Out in the quiet between stars, that delay only gets longer. Light has to cover absurd distances. During that travel, nothing about the beam screams 15 million years are passing. It just goes. For light, in a very strange sense, there is no time between leaving and arriving. But for us, tracking it from the outside, those journeys become one of the few clear ways to talk about cosmic time at all. It's a little like listening to distant thunder after seeing lightning. You count the seconds between flash and boom to guess how far away the storm is. The delay becomes a ruler. On a cosmic scale, the distances are so huge and the speeds so fixed that the delay isn't just a hint. It is the history. This is where the emptiness becomes important. If the universe were crowded everywhere, full of stuff, light would be bumping into things constantly. We'd never see far. The fact that there are vast empty stretches means light gets to keep going, preserving a record of events long after the things that produced it have changed or died. In a way, the void between stars is the universe's archive. It's where the stories sit, traveling, waiting to be read. If you're out there in that emptiness with your tiny pro clock, your proper time is still ticking. If you have a heartbeat, that's still beating. If you blink, that still takes however many milliseconds it always did. Locally, your experience of seconds doesn't flatten just because the scenery is boring. But your relationship to everyone else's time gets stretched almost comically. Say you're halfway between galaxies, and you look one way and see the faint smear of our Milky Way, and the other way and see another galaxy. Light from each has taken millions of years to reach you. For each of those galaxies, your now is pinned to their deep past. There is no sensible way to combine all of that into a single, universal answer to what time is in the universe. The best we can do is pick convenient reference frames. Time since the Big Bang based on cosmic expansion, or the age of a star based on how it shines. Each is a different cut through the giant, tangled structure of events. The main thing the emptiness teaches you is that time doesn't need noise and busyness to exist. It doesn't require drama. It just needs two things: a structure, space-time itself, and at least occasional changes happening within it. Between stars, changes slow down. Gas clouds drift. Over incredibly long periods, they might drift into each other, collapse, form new stars, start the whole bright story over again. But if you zoom into the scale of your own life, years, decades, those regions look frozen. Nothing new appears. No light switch on or off. Just quiet. If you live there, your own small changes would dominate your sense of time. Your heartbeats, your thoughts, your habits. The universe outside would feel like a static painting. But the painting wouldn't actually be still. It's just that its changes play out on a time scale so far beyond your own that your little slice of proper time can't resolve them. It's a bit like watching a tree. Stand in front of it for an hour, and it seems completely still. Its branches sway in the wind, its leaves rustle, but the tree nest doesn't change. Come back in 20 years, and that same tree is taller, thicker, maybe gone. Time was doing its work all along. You were just sampling too short a window to see it. The spaces between stars are like that hour stretched out into millions of years. On the scale of a human lifetime, there is still photograph. On the scale of cosmic evolution, there is slow-motion movie of matter wandering, meeting, and occasionally collapsing into new things. That kind of time is almost impossible to feel. Your body isn't built for it. Your internal clock maxes out somewhere around "this took all day, and I haven't seen you in years." Try to imagine 100,000 years or a billion, and your mind either goes blurry or cheats by turning it into a stack of familiar units like a million lots of a year, which doesn't actually help. So you end up with this strange disconnection. Your sense of time is tuned to the quick, noisy layer of the universe, weather and conversations and traffic and heartbeats, while the main dynamics of the cosmos are moving deep underneath you at a speed you can barely comprehend. In that gulf between your time scale and the universe's, the question, does the universe know what time it is, quietly rearranges itself. Maybe the universe doesn't have a clock that ticks in seconds or years at all. Maybe its time is better described in phases. Hot and dense, cooling and expanding, stars igniting, stars dying, space thinning, everything fading. Those phases are marked in the emptiness. The cosmic microwave background, that faint hum that fills all of space, is a fossil from when the universe was young and hot. It's still cooling as the universe expands. If you could compare it now to what it was billions of years ago, it would be colder. You can't directly because you weren't around then. But different parts of that light, coming from different distances, show you different ages. Empty space itself is carrying a clock in its temperature. It's just a clock that ticks unimaginably slowly by human standards. Back here in your room, the emptiness between stars feels very far away. Your main experience of void is maybe that weird mental silence when you don't know what to say in a conversation. But the same laws that rule the quiet between galaxies rule the air in your lungs and the room around you. These big, empty stretches are like training wheels for another idea that's coming, the arrow of time, and why the universe's story seems to move in one direction rather than another. To understand that, you have to understand how things can be still for a long time and then suddenly not. How a cloud can drift for eons and then collapse into a star. How a universe can be almost uniform and then slowly spatter itself with structure. The emptiness isn't between moments. It is a moment stretched out. Part of the story, not the pause between chapters. Time moves through it in the same sense that time moves through your day, by letting some configurations happen and others become impossible. You don't feel the ticking of the cosmic background. You barely feel the age of your own species. You feel the softness of your blanket, the slow rhythm of your breath, the way your eyes are a little heavier than they were when we started. Those are your clocks. They're honest, but they're local. Out there between stars, another kind of clock is running. Lights sliding across nothingness, carrying news from places long changed. And beneath both of those at a deeper level is the geometry itself, the way space-time is shaped and stretching, setting the boundaries for what can happen and when with no audible tick at all. If the universe knows any time, it's that bottom layer, the pattern of where change can go next. Everything else, your seconds, your subjective minutes, your centuries, is just the way different little corners of that pattern experience their own slice of it. If that bottom layer of time is really just the pattern of where change can go next, then you can't help wondering what the pattern looked like at the very beginning. If you could grab the whole universe and slowly drag the slider backwards, frame by frame, all those drifting galaxies and quiet voids and noisy black holes unhappening in reverse, where would you end up? Let's try it. Keep lying where you are. You don't have to move anything except your imagination. Take the universe as it is now, wide, old, full of structure, and start rewinding. Galaxies that are currently sliding away from each other in all directions start to creep back together. The gaps between clusters shrink. The great dark spaces we just visited begin to fill in. The cosmic web tightens. You're not changing the rules. You're just running them in reverse. Keep going. Stars that were slowly burning through their fuel are now unburning. Supernovae that scattered heavy elements across space collapse back into massive stars. Planets unform and fall back into disks of dust and gas. Those disks swirl backwards into smooth clouds. The universe, on average, is getting hotter and denser as everything squeezes together. Time still makes sense here. You can still order events. This happened, then that, but the scenery is changing. There are fewer distinct objects, fewer sharp boundaries. Structure is being undone. Rewind a bit more, and the galaxies themselves blur. Instead of neat spirals and blobs, you've got something more like one big storm of matter and radiation, stirred but not yet differentiated. Stars are rare, then gone. It's just a cosmic fog, hot and crowded. Physics is still in charge. Gravity, electromagnetism, nuclear forces, all doing their thing. But as you keep rewinding, the temperature climbs so high that ordinary atoms can't exist. Electrons are stripped off nuclei. Everything is a plasma, a charged soup of particles bumping into each other constantly. At around 380,000 years after the beginning, in forward time, that plasma thins enough for atoms to form and for light to travel freely. In reverse, we're heading toward that moment. The cosmic microwave background, the ancient, stretched light filling the universe, is getting hotter and hotter as our rewind squeezes it. That gentle microwave haze shifts through radio, through infrared, through visible light, all the way back up into a blinding brightness. Eventually, the universe becomes opaque again. Light can't travel far without being scattered. The cosmic picture dissolves into a glowing fog. Keep dragging the slider back. The fog gets denser, hotter, more uniform. We're deep in the territory where star and planet and galaxy don't mean anything yet. If you dropped a version of yourself in here, you'd have nowhere to stand and nothing to look at except light and particles and a sense of everything being very busy and very pointless. Still, time is doing what it always does, letting one state turn into another. Collisions, reactions, decays. But the diversity of those states is shrinking. The universe is losing complexity as we rewind. Now we're down from hundreds of thousands of years to minutes, then seconds after the beginning. This is the part you can't experience, but we could describe like someone narrating a thunderstorm you only see as a smear through the curtains. At about 1 second after time zero, in the forward direction, the universe is a seething mix of protons, neutrons, electrons, neutrinos, photons, all compressed into a volume much smaller than today's visible universe. Temperatures are in the billions of degrees. Nuclei are just starting to form, little clusters of protons and neutrons that will eventually become the first hydrogen and helium. Rewinding through that second, those nuclei fall apart again. The protons and neutrons go back to being free, then themselves dissolve into quarks and gluons, the building blocks of what we usually call particles. Everything is so hot and dense that nothing can stay assembled for long. Another step. Now we're in the first tiny fraction of a second. The forces of nature that you treat as separate, electromagnetism, the weak nuclear force, the strong nuclear force, begin to merge as we go back. At higher and higher energies, they stop acting like distinct characters and behave more like different aspects of one underlying interaction. This is the domain of particle physics experiments trying to recreate early universe conditions, smashing particles together at high energies to see what falls out and what the rules might have been back then. Our rewind is taking us through that, past it, into a regime where we don't really know the script anymore. The equations we use now start to lose their confidence. Somewhere earlier than about 10 superscript 3 seconds, the ridiculous, unimaginably small sliver of time when inflation is supposed to have happened, everything gets blurry. Inflation is the idea that the universe very, very early on expanded not just quickly, but explosively quickly. Space itself ballooned, stretching tiny quantum fluctuations into large-scale structures, smoothing and flattening the cosmos. Run that backwards, and you're watching the balloon rapidly shrink, pulling everything closer than close. The patch of space that will one day become everything you can see in the night sky shrinks down to something microscopic. Before inflation, whatever region existed was much smaller, much denser, much hotter, and, this is the spooky part, perhaps much simpler. We've now backed ourselves up all the way to the edge of what our current physics can meaningfully talk about, the time-zero region, where the universe appears in our equations to have had infinite density and temperature. We call that the singularity, but the word is really scientist speak for our math throws up its hands here. It's very tempting to picture the singularity as a literal point in space, a little dot where everything started. But that's not quite right. Space itself is part of the thing that's shrinking as you rewind. There isn't a little dot sitting in a pre-existing room. The room itself is collapsing. You're not watching an explosion in space. You're watching the expansion of space. If time is one of the directions in that space-time, then when you get all the way back to the beginning, something very uncomfortable happens. There may simply not be a before. That's the part our brains hate. They're so deeply wired around cause and effect. This happened, then that they want to ask, okay, but what was before the Big Bang? As if we're asking, what was in the house before you moved your furniture in? Physics, irritatingly, says that might not be a meaningful question. If time itself is a coordinate that begins at the Big Bang, asking what happened before it is like asking what's north of the North Pole. You can say the words. You can imagine walking more north. But eventually you end up going south again because you've run out of north. The concept stops applying. In many cosmological models, time zero isn't so much a brick wall as a smooth boundary. Just as latitude starts at the equator and reaches a natural end at the pole, time might start at the Big Bang, and that's it. There's no earlier. Not because we can't see it, but because earlier doesn't exist in the same way. Other models fight back against that discomfort. They propose bounces, a universe that contracts, reaches a minimum size, and then expands again. In that picture, our Big Bang was the moment of rebound, and before was a previous phase of the universe, maybe with its own arrow of time, its own story. Some versions suggest an endless sequence of cycles. Others say it was a one-off, a unique transition that gave rise to the rules we see now. Still others go more radical and say that time, as we know it, might be emergent. That beneath the level of particles and forces, there could be something more abstract. Networks of relationships, bits of information, that give rise to the appearance of time when organized a certain way. In that view, asking about the start of time is like asking about the start of temperature. There's no temperature in a single particle. It emerges when you have lots of them interacting. Whichever version you prefer, they all agree on one thing. If you rewind far enough, time stops looking like the smooth line you use for your calendar. It stops being the comfortable background you lean on and becomes something uncertain, maybe not even fundamental. And yet, when we fast forward from that edge, from whatever weird, compressed state the universe started in, we get a remarkably well-behaved story. The first second after the Big Bang is chaos by our standards, but it's orderly chaos. Rules emerge. Forces differentiate. Particles form and survive. After a few minutes, the first nuclei settle down, mostly hydrogen and helium in specific ratios that we can still measure today. Those early moments leave fingerprints that haven't been erased. All the time you've lived, all the time any human has lived, All the time stars and galaxies have gracefully spun and collided and shone and died, sits on top of that first second like a cliff on top of a foundation stone. There's so much above it that it's easy to forget it's there. But if that stone had been different, everything above would be too. And maybe the strangest part for you personally, lying here tonight, is this: the time you're experiencing right now traces a straight line back to that first second. Your heartbeat, your thoughts, the age of your bones. The time on your phone, which links to network clocks, which link to primary standards, which are calibrated against atomic transitions and astronomical observations and models of Earth's motion, which are all, in turn, part of a universe whose age we measure by how long it's been expanding since that hot, dense beginning. When you casually say, the universe is about 13.8 billion years old, you're really saying, given how fast space is stretching right now, given how the light from distant galaxies has been redshifted, given the cooling of the cosmic background, we can fit a smooth curve backwards that hits a start line that long ago. That age is a kind of cosmic birthday, counting from time zero for our observable patch of spacetime. If there was anything before, it's not part of this tally. Our clock starts with the Big Bang, in the same way your personal age starts with your birth, even though lots of things happen before you. So when you wonder if the universe knows what time it is, one possible answer is yes, in the sense that its large-scale structure keeps a record of how long it's been since that beginning. The spacing of galaxies, the temperature of the background radiation, the relative abundance of hydrogen and helium. They're like marks on the wall showing how tall a child has grown. It doesn't know the time in hours and minutes. It doesn't care that your alarm goes off at 7 a.m. But it has an internal sense of early and late written into the way it has expanded and cooled. Early, hot, dense, uniform, simple. Late, cooler, more spread out, full of structure, then eventually fading. We're somewhere in the middle. Not too early, not too late. Old enough that galaxies and planets and brains and YouTube exist. Young enough that the stars still shine. You could see your whole life as a tiny, delicate loop of proper time attached to that vast cosmic curve. Your first cry, in this exact moment, exists at two tiny points on the universe's big timeline. Both are stacked on a foundational first second that you never experienced, but that made your experience possible. If you could somehow replay that first second in front of you like a slow-motion movie, it wouldn't look like anything you'd call a day or a night. It would be pure change, pure transformation. No clocks, no schedules, just the universe figuring out what it could be. By the time your species showed up with its bones and its calendars and its anxieties about being late, the raw chaos had cooled into something remarkably predictable. Planets could orbit steadily. Stars could burn for billions of years. Time could be chopped into days and months and years and feel, for the most part, steady. But underneath that steady feeling is the knowledge that it all began in a moment where steady didn't exist yet, where time itself was just getting started, or maybe just becoming visible. You, tucked in a bed under a comparatively cold and quiet sky, are about as far from that moment as you can be in every sense. And yet, that moment is baked into you. The elements in your blood, the photons hitting your eyes, the cosmic background bathing the room without your permission. All of them are echoes of that first second's rules. When you ask what time it is for the universe, one answer is, it's however long it's been since that second stopped being the only thing and started becoming the foundation for everything else. We've pulled the whole universe backwards, all the way to that blinding first second. Watch structure come undone in reverse. Watch light get hotter, distances shrink, rules roll back towards something simpler and stranger. Then we let it go again, like releasing a spring, and everything rushes forward. Atoms form, stars ignite, galaxies swirl, planets cool, people argue in comment sections. And through all of that, one feeling never goes away. Time moves in one direction. You can remember your breakfast, but not your retirement. You can drop a mug and watch it shatter. You can't drop a pile of ceramic shards and watch them calmly hop into the air, assemble, and land in your hand, ready for coffee. You get older. You do not, under any remotely normal circumstances, measurably get younger. The physics you've met so far is annoyingly neutral about this. Most of the fundamental equations don't care about direction. Run them forward, they work. Run them backward, they still work. A movie of two billiard balls colliding, played in reverse, still respects the rules of motion. A planet orbiting a star looks just as legitimate when you rewind its path. So where does this one-way feeling come from? Why does your life move from is to not yet, and never the other way around? The hint has been lurking in the background of almost every example without announcing itself. It turns up whenever you mix things. Cream in coffee, perfume in a room, heat in a metal spoon. You start with separation, with some sort of order or contrast, and end up with spread-out sameness. Physicists give that tendency a name: entropy. Entropy sounds like a villain in a Marvel movie, but it's really just a measure of how many different ways a system can be arranged while still looking the same from far away. High entropy means lots of possible microscopic arrangements. Low entropy means fewer. Take a neatly stacked pile of books. From a distance, it has a clear, ordered look. There are only so many ways to stack them like that. Kick the stack over and let the books scatter all over the floor. Now there are countless ways they can be spread out and still look messy in roughly the same way. Neat pile, low entropy. Mess, high entropy. The same idea applies to a box of gas. Start with all the molecules trapped in one corner and the rest of the box empty. That's a very special arrangement. There aren't many ways to pull that off. Let the gas go and the molecules rush out and fill the box. Once they're spread out, there are countless microscopic patterns they could be in. You can't tell the difference just by looking. Full box is full box to your eyes, but there's a huge number of underlying configurations. That's high entropy. The second law of thermodynamics, which sounds like something a teacher would say right before you fall asleep in class, is really just a fancy way of saying, in a closed system, the entropy tends to increase. Things move from fewer possible microarrangements to more. Not because disorder is stronger or wants to win, but because there are more disordered arrangements than ordered ones. If you shake the box, the odds overwhelmingly favor the gas ending up evenly spread out rather than politely clustering back into the corner. Once you see that, your everyday one-way processes start to look less magical. The cream doesn't leap back out of the coffee because there are so many more ways for it to stay mixed than for it to unmix itself by chance. The mug doesn't reassemble because there are absurdly more ways for shattered pieces to stay scattered than there are for them to just happen to collide in exactly the right pattern at exactly the right speeds. Entropy is the quiet bookkeeper under all of this. It doesn't push things. It doesn't have feelings. It just counts possibilities, and the universe tends to drift toward more possible arrangements. That drift is what gives time an arrow. You can flip the equations of motion and imagine each collision in reverse, but the sheer number of underlying states makes one direction overwhelmingly more likely to happen in practice. That direction, we might as well call it forward, is the one where entropy goes up. You've seen this in miniature your whole life. An ice cube melts in a warm drink. Heat spreads out. It doesn't spontaneously concentrate itself into a cold pocket. Your bedroom naturally becomes messy after a week of being a human in it. It does not naturally become cleaner unless you spend energy to move everything back into a lower entropy arrangement. Your own body is an entropy machine. You take an energy in the form of food, structured molecules full of potential. You breathe in nicely ordered air. Your cells do their complex, low-entropy dance. The price they pay is heat and waste. More random motion, more disordered molecules being pushed out into the environment. You stay alive by increasing entropy around you. It sounds rude, but it's actually the only reason structure like you can exist at all in a universe that favors disorder. Local pockets of order are allowed, as long as, when you do the math for the whole situation, body plus surroundings, the total entropy goes up. So here is the twist that takes this from time feels one way to time is one way in a deep sense. For the second law to have any bite, you have to start from a low entropy state. If the universe began already in a high entropy, maximally disordered configuration, there wouldn't be a preferred direction for things to go. It would already be as scrambled as it could be. The second law would sit there with nothing to do, like a smoke alarm in a house made of water. Instead, the early universe we rewound to was weirdly ordered. Hot and dense, yes, but remarkably smooth. On large scales, almost the same everywhere. Tiny fluctuations, tiny variations, but basically low entropy, especially when you include gravity properly in the calculation. That low entropy beginning is the deep reason you have an arrow of time at all. From that kind of starting point, there are a huge number of higher entropy ways to rearrange things. There are many more possible futures than possible pasts. So the system, left to its own devices, explores those futures rather than improbably marching back into something even smoother. Structure, stars, galaxies, planets, life, actually appears along that road. Paradoxically, as the total entropy goes up, pockets of order blossom. Gravity pulls matter together into clumps, forming stars and galaxies out of the smooth soup. Those clumps can burn, radiate heat away, and help drive entropy higher overall. You're living inside that long drift from low entropy to high. That drift is what gives you the feeling of before and after in the first place. Look at your own memories for a second. You remember the past because information about it has been written into the present. In your brain, your journal, photos, scars, all the tiny changes that stuck. You don't remember the future because its information hasn't been written yet. The processes that will create those future states haven't happened. Memory itself is entropic. Recording anything, forming a stable trace of an event, takes energy and increases entropy somewhere. Every time your brain strengthens or weakens a synapse, it's doing physical work. Every time your phone saves a photo, its storage hardware is doing work and dissipating heat. All that record-keeping only happens forward. The past leaves footprints. The future doesn't because it hasn't walked through yet. That's why your subjective arrow of time lines up with the entropic one. You're built out of matter obeying those same rules. Your mind, your story, is part of the same tendency. So when you think of that first second again, hot and simple and uniform, it's not just back then. It's also low entropy. From that start, it was overwhelmingly more likely the universe would end up in a future where cream is mixed, mugs are shattered, stars have burned, galaxies have collided, and a person is lying in bed listening to someone ramble about entropy, than in a future where everything somehow unscrambled itself. You can imagine a weird, statistical miracle where all the air molecules in your room just happen to collect in one corner, leaving the rest of the space vacuum. The laws of motion don't forbid it. It's just so absurdly unlikely that you could wait longer than the age of the universe and never see it. In that sense, the arrow of time is not a sharp rule carved into stone. It's more like a statistical avalanche. You can walk uphill locally, with effort, clean the room, refreeze the water, assemble complex machines, but the slope underneath is always pointing toward more ways to be spread out. You might be wondering what happens to this arrow in those extreme places we visited earlier. Near a black hole, where time dilates and paths through space-time bend into strange shapes. Does entropy still increase? Do mugs still shatter? Do stars still burn out irreversibly? Yes. As far as we can tell, the second law holds there too. Black holes, in fact, are deeply tied up with entropy. They seem to have enormous entropy proportional to the area of their event horizons. The details live in some of the trickier corners of theoretical physics, but the moral is simple. Even the most extreme gravitational objects follow the same one-way logic. Information falls in, entropy goes up. The arrow survives. When we talk about the heat death of a universe, the slow fade into a state where everything is so spread out, so uniform, that nothing interesting can happen anymore, we're really talking about entropy reaching its maximum. No more gradients. No more temperature differences. No more fuel for stars to burn or for life to run on. In that final, featureless state, the arrow of time would lose its meaning. If nothing's changing, if no new records are being written, if every region looks identical and stays identical, then later stops being a useful concept. You could still write T equals 1 trillion years into a physics equation, but physically, that label wouldn't correspond to anything new. There'd be no more increase in entropy, no more events to separate one moment from the next. In that sense, time doesn't exactly stop. It just runs out of things to distinguish. It becomes, from a universe's perspective, irrelevant. Right now, you're nowhere near that. Stars are still on. Planets still move. Life still burns through energy in wonderfully inefficient ways. Entropy is climbing, busily grinding contrast into uniformity on large scales, all while stirring up local complexity in the process. Your own life is one long ride down that slope. You started in a very low entropy state, a tiny, highly ordered configuration of cells, and you've been increasing your personal entropy ever since in a very slow and graceful way. Your body fights local battles against disorder, repairing DNA, pruning neurons, cleaning up cellular junk. But it does so by burning through energy and raising the entropy of your surroundings. When you think back across your years, the direction is always the same. Childhood, first heartbreak, first big choice you regret or cherish, the string of days that led to you lying here right now. You can't reorder those moments in any physically meaningful way. The universe doesn't offer a mechanism to let your 30s happen before your teens and still keep all the same experiences. That consistent direction isn't something physics bolted on top. It's a byproduct of how the whole thing started and how probability works in large systems. So when you ask, why does time only go forward? One answer is, because the universe began in an astonishingly low entropy state and has been exploring higher entropy configurations ever since. That exploration is what gives you history, memory, decay, growth, aging, and every familiar sign that yesterday is not tomorrow. And when you ask, does the universe know that? You have to laugh a little because in a way, yes. Not as a conscious thought, not as a ticking clock labeled entropyometer, but as a simple fact written into every process that unfolds. Atoms that once rattled around freely in a hot plasma now sit in your bones. The energy that powered your thoughts today came from sunlight trapped in plants, trapped in food, broken down in your cells, converted into motion and heat. Each link in that chain increased entropy in some way. Each step left the universe a tiny bit more spread out in its possibilities. You are a very elaborate way for the universe to turn low-entropy arrangements into high-entropy ones while telling itself stories about what that feels like. You lie there and think, time keeps moving. I can't go back. And somewhere beneath that thought is a simpler statement. The past is a special, more ordered set of configurations. The future is a bigger, messier set, and I'm riding along as the universe wanders from one into the other. It doesn't make deadlines less annoying. It doesn't fix the feeling that some days rush and others crawl. But it does give you a deeper picture of what's underneath all that. Not a tyrant forcing everything to march in lockstep, but a quiet, statistical slope that makes one direction much more likely than the other. The arrow of time is not painted on the universe from outside. It's grown from within, out of the way things are arranged and the way they were arranged at the start. Every broken egg, every melted ice cube, every aging star, every worn-out pair of shoes is pointing very gently in the same direction and saying, this way is forward. So far, you've watched time behave like a big, smooth river. It flows with an arrow, guided quietly by entropy. It curls near black holes, stretches between galaxies, carries the story from that first hot second to you lying here now. But if you zoom in, really in, down from stars to atoms to particles to whatever sits at the bottom of matter, that smooth river starts to look very different. It stops being a river and starts looking like something more jittery, more pixelated, more like rain on a window than a clean stream. This is where quantum mechanics shows up, looks at your comforting picture of time, and just shrugs. In the everyday world, you're used to things having clear positions and velocities. A ball is here, moving this fast, in this direction, at this moment. If you know enough about it, you can predict where we'll be a second from now. That's the old school, classical picture. The quantum world doesn't play that game. Take a single electron. Don't imagine it as a tiny marble. Imagine it as a kind of smeared out possibility cloud. Before you measure it, it doesn't really have a definite position in the way your keys do when you can't find them. It has a range of possible positions, each with some probability. That range is described by something called a wave function, which is basically a mathematical way of saying, here are all the places this thing might be and how likely each one is. Time shows up in the equation that tells the wave function how to evolve. It's there as a parameter, like a label you attach to different frames of the universe's microscopic movie. The wave function at one time, the wave function a little later, and so on. But notice what time isn't doing there. It's not a fluctuating object. It's not something the wave function can be in superposition of. It's just the thing you feed in to ask, okay, what do the probabilities look like now? Already that's a little suspicious. All the other quantities in quantum mechanics, position, momentum, energy, spin, come with uncertainty, with jitter, with superpositions. Time just sits outside the tent, pretending to be classical and well-behaved, while everything inside is partying in probability space. Now imagine you actually run an experiment. You've got that electron in a trap. The wave function says there's some spread in where it might be. At a certain moment, you switch on a detector, some device designed to interact with the electron and register its presence in one particular spot. Before that detection, the electron isn't in this place or that place. It's in a superposition of many possible places. After the detection, you find it here. A single dot, a single outcome. The wave function, which used to be spread out, has, according to the simplest story, collapsed. Here's where time gets jittery. Quantum mechanics doesn't tell you exactly when that detection will happen. It doesn't give you a neat schedule like at t equals 0.01234 seconds from now, the electron will definitely hit the detector. Instead, it gives you probabilities over many runs of the experiment. The clicks form a pattern that matches what the wave function predicted. But each individual click happens at a time you can't predict ahead of time. You can set things up so that, on average, they happen roughly once per second or once per hour or whatever. But the actual sequence might be click, 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 like a Geiger counter listening to radioactive decay. There's a rhythm, but it's irregular, jittery, not the smooth tick-tick-tick of a classical clock. Radioactive decay is a perfect example. Take a bunch of identical unstable atoms. Each one might decay and spit out a particle. You can't say when any single atom will go, but you can say something about the group. Maybe the half-life is 10 minutes, which means that after 10 minutes, half of them will have decayed statistically. But any particular atom could decay in the first second or sit there stubbornly for hours before finally going. At the level of one atom, the time of decay is fundamentally random. Not random because we're dumb and don't have enough information. Random because that's just how the universe behaves down there. Time, for that atom, is a waiting room with no appointment, just a chance distribution. Zooming in like this, your nice continuous image of time as a smooth flowing coordinate starts to stutter. Quantum events don't happen in a perfectly predictable rhythm. They're more like raindrops on a roof. You can measure the average rain rate, but not which exact shingle will be hit next and when. You might ask, okay, so time is jittery for particles, big deal. Why does that matter for me? Because you're built out of those particles. Every neuron firing in your brain is a chain of quantum events. Every chemical reaction in your cells depends on electrons jumping between energy levels, atoms vibrating, molecules doing their weird quantized dances. On paper, We often approximate all of that with smooth, classical equations because it's easier and mostly accurate on large scales. But under the hood, there's still that quantum jitter. You don't feel it directly. You don't sit up in bed thinking, ah yes, my wave function is evolving. Your macroscopic time, the time of seconds and minutes and days, is what you get when you average over insane numbers of these microscopic events. The jitter cancels out into something that looks smooth and regular, the way the chaos of individual gas molecules becomes smooth pressure and temperature in a balloon. Underneath that smoothness, though, quantum weirdness is doing something else important. It's helping to define what events are in the first place. Remember that wave function describing possibilities? Left alone, it evolves smoothly, but the world is never really left alone. Particles interact, systems bump into each other, exchange energy, become entangled. That entanglement, the spooky link between particles that makes their properties correlated even when they're far apart, isn't just a party trick. It's what makes measurement and, in a sense, time meaningful. Picture a very tiny system, something simple like an atom that can be in one of two energy states, low or high. Quantum mechanics says it can also be in a superposition of those low and high at once, in a way your ordinary language struggles with. That superposition evolves in time, described by a wave function that spreads its weight between the two options. Now let that atom interact with something bigger, like a measuring device, or a photon, or a dust grain. They become entangled. The state of the atom is now linked to the state of the bigger thing. If the atom is low, the device is in one configuration. If it's high, the device is in another. But the wave function, before any definite result is recorded, holds both possibilities. As more and more degrees of freedom get involved, the air molecules, the table, your eyes, this entanglement spreads. The superpositions become incredibly complex. And a strange thing happens. From the point of view of any one small part, it starts to look like the system really has chosen one definite result. This process is called decoherence. You don't need the technical details, just a rough picture. Quantum fuzziness gets smeared out into the environment, and what's left behind locally looks like a classical, definite event. That's where your sense of time steps comes from. An atom was in some fuzzy, maybe low, maybe high state. Then after decoherence with the environment, you have a definite, it's low, that sticks around and can be used as a record. That record lets you say before and after. Before, the atom was in a superposition. After, it's in a low state, and the rest of the world carries evidence of that choice. That evidence might be a photon in your eye, a line in a computer file, a tick in a detector. Each is a small knot of increased entropy, a little bit of order that costs some energy to create. Stack enough of those little knots together, and you get what you call a timeline. From this point of view, time isn't just a parameter in an equation. It's the accumulation of irreversible records, written into the environment through decoherence. The quantum world, left to its own devices, would just evolve a wave function in a parameter called t. But the moment you have complex systems interacting, that evolution starts to carve a direction into reality. More entanglement, more records, more entropy. It's like a very weird library where the only way books can be written is by making the shelves messy. Now add entanglement across space. Two particles interact, then fly apart. According to quantum mechanics, their properties can remain correlated in a way that doesn't fade with distance. Measure one here, and you instantly know what result you'll get if you measure the other there, even if there is halfway across the galaxy. This doesn't let you send messages faster than light. It doesn't violate relativity. It just tells you that underneath the classical picture of separate objects moving through time, there's a deeper layer of joint states. Events don't only happen to one particle or the other. They happen to the whole entangled system. In that deeper layer, the neat sequence first this, then that gets fuzzy. Which measurement happened first can depend on your frame of reference. In some setups, what looks like cause in one frame looks like effect in another, and vice versa. Yet the correlations always line up perfectly when compared later. You live in the classical shadow of all that. Your everyday time feels like a single, clean line. But underneath, there are these quantum networks branching and linking, forming a kind of tangled web where one is not as simple as it seems. This tangle becomes a real headache when physicists try to merge quantum mechanics with general relativity. Gravity tells us space-time is a flexible fabric. Quantum mechanics says fields and particles live on that fabric and obey probabilistic rules. Put them together, and you'd like a single neat equation that describes the quantum state of space-time itself. Some attempts at that give you something called the Wheeler-DeWitt equation. You don't need the form of it. The weird part is that, in some versions, time just isn't in there. The fundamental equation for the wave function of the universe doesn't have a time parameter at all. It describes a static object, all possible configurations, all at once. If that's actually the right way to think about things, then time as you experience it, this flowing, jittery, ordered series, might be something emergent. Not a basic ingredient of reality, but a pattern that appears when parts of the universe look at other parts and call them clocks. You can get a glimpse of this idea in a simpler way. Imagine the universe as one big quantum system. Now split it conceptually into two pieces. A small part you'll call the clock, and the rest you'll call everything else. The clock might be a particular atom, a swinging pendulum, your heartbeat. Doesn't matter. Instead of asking, how does everything change in some external time? You ask, how does one part change relative to the other? When the clock is in this state, what state is the rest of the universe in? When a clock is ticked twice, what's changed elsewhere? Time becomes a relationship, not a universal background. It's the way subsystems of the universe keep track of each other's evolution. Your own experience fits this surprisingly well. You don't perceive abstract T. You perceive the sun is higher than it was, my phone battery is lower than it was, my stomach is emptier than it was. You compare now to before using clocks inside you and around you. Those clocks are just particularly reliable physical processes. The swing of a pendulum, the vibration of an atom, the beat of a heart. At the quantum level, each of those processes is a huge ensemble of jittery, microscopic events, smoothed out into a regular rhythm by statistics and feedback. They lend their apparent smoothness to your idea of time. Strip away the smoothing, zoom all the way down, and time becomes a sea of probabilities evolving under equations that don't care about direction, punctuated by sudden, irreversible decoherence events when one possibility becomes actual and leaves a mark. From that jittery perspective, the question, does the universe know what time it is, morphs again. On the quantum scale, the universe doesn't carry a neat timestamp on each particle. It carries amplitudes, weights for different possibilities. Time enters as a parameter in how those amplitudes change, and as a history of which superpositions have decohered into definite outcomes. It knows time to the extent that there is a sequence of these outcomes, each entangled with the last, each written into the fabric in the form of increased entropy and recorded correlations. Without those, the wave function would just sit there, all possibilities hovering at once, with no sense of before or after. Your mind is one of those recording devices. It sits on top of an ocean of quantum jitter and, somehow, assembles a story. This happened, then that, then I felt this, then I thought that. Underneath, nothing guarantees that stories should exist. The equations would work perfectly fine without a narrator. But the fact that you are here, narrating, means that quantum time, with all its jitter and randomness, has been working hard for billions of years to create systems stable enough to remember and wonder. You don't have to solve any of this tonight. You don't have to decide whether time is fundamental or emergent, smooth or jittery, a line or a web. You can just lie there and let the thoughts sit with you. Every second you feel is built from countless tiny, unpredictable clicks under the surface. Every smooth minute is woven from an unimaginable number of quantum jitters. And somehow, out of all that, You get a sense of a continuous now, moving steadily forward, carrying you gently along. The quantum stuff is wild enough on its own, but the real plot twist is this. Even if the universe handed you a perfectly clean, perfectly regular timeline, your brain would still mess with it. It can't help it. That's how it's built. You don't experience time the way a stopwatch does. You experience a story, a sequence, a feeling of that was then, this is now, and something else is coming. And that feeling is very much a construction, layered on top of the physics the way a dream is layered on top of whatever your body is doing in bed. You can feel it even now as you listen. There's the slow rhythm of my voice, the little gaps between sentences, the way your attention wanders and comes back. It doesn't all arrive as clean, separate frames. Your mind smooths it into something continuous, like a film projector hiding the fact that it's just flipping cards fast. The first thing to know is that there is no master clock in your head. No little metronome in the middle of your brain going tick, tick, tick. Instead, you've got a whole collection of clocks, each tuned to a different span of time. Deep in your brain, above where your nose would be if you peeled the layers back, sits a cluster of neurons that acts as a rough day night timer. It's sensitive to light coming from your eyes. It keeps track of roughly 24 hours, nudging your hormones and body temperature and sleepiness up and down in a cycle. It doesn't know what 10:42 p.m. is. It knows getting dark now and time to wake up soon. That's one kind of time. Elsewhere, like in your cerebellum and basal ganglia, you've got circuits that specialize in short intervals. A tenth of a second, a few seconds. They help you clap in rhythm, swing your foot, and land on a step. Pause exactly long enough before finishing a sentence so it sounds right. The prefrontal cortex, up behind your forehead, helps you hold longer intervals in mind. Minutes, hours, the vague sense that it's been a long day or wow, that meeting took forever. It's less precise, more emotional, more tied to attention and boredom and stress. None of these clocks ever fully agree. They're like three chronically late friends trying to pick a restaurant. One says it's been 5 minutes. Another insists it must have been 20. The third is just wondering what's for dessert. Yet somehow, from their messy overlap, you get a reasonably stable sense of past, present, and near future. Not perfect, just good enough to cross a street without dying and to show up to things more or less on time. You can see the cracks if you look closely. Think about all the times you've said, wow, where did the time go? You looked up from your phone or a book or a conversation, and hours had slipped past almost unnoticed. Or the opposite, a 5-minute wait felt like half an hour because you were anxious or bored. The external clock didn't change. The seconds are the same length. What changed was how many events your brain packed into those seconds, and how much attention it burned doing it. The busier your mind is with new, interesting stuff, the fewer separate markers it lays down. Later, when you look back, the stretch feels short and smooth. That afternoon flew by. There just isn't that much stored detail to give it weight. When you're stuck in a situation where very little is happening, like staring at a loading screen or waiting for a reply to a risky text, your brain obsessively checks for change and finds almost none. So it starts counting the checking itself. Tiny, repetitive, uncomfortable moments stack up. Later, that stretch feels long and thin. That took forever, even if it didn't. Novelty plays a big role. Children experience time differently partly because everything is new. A single year at age 6 is an enormous slice of remembered life. New smells, new schools, new faces, new skills. The brain is constantly recording. Later, those early years feel rich and spread out like a long summer. By the time you're older, a lot of days blur. You commute the same way, talk to the same people, eat similar meals. There's nothing wrong with that. It's just efficient. But when your brain compresses the memories, whole months can collapse into a few vivid points. Wasn't it just January? It wasn't. Your mind just didn't see much reason to save all the copies. That compression is the secret trick running in the background. Your sense of time is tied not to clocks, but to how much change you store. You can see this mischief at work in some very specific illusions. There's a thing called the stop clock illusion. You glance at a clock with a sweeping second hand, and for just a moment, the hand seems to freeze. Then it starts moving normally. It's like time hiccups. What actually happened is that your eyes made a quick movement, a saccade, to flick from one thing to another. During that flick, your brain suppresses visual input. Otherwise, you'd see a nauseating blur every time you shifted your gaze. When the new image appears, your brain quietly backdates it to cover the gap. So the picture of the clock you see after the eye movement gets stretched backward in time a bit, and the first second after you look feels longer than it is. The outside world is steady. The weirdness lives inside your processing. The same kind of thing happens in crisis moments. People who've been in car accidents sometimes report that everything went into slow motion. They watched events unfold with this eerie, stretched clarity. What's happening isn't that physics suddenly took pity on them and dialed reality down to half speed. It's that the brain, dumped full of adrenaline, started sampling the world more intensely. More snapshots per real-world second. Later, when those snapshots are played back as a memory, the event feels like it lasted longer, with more frames. Your brain is not a passive clock. It's an editor. It fills gaps, rewrites order, and bends perceived lengths to keep your experience coherent and useful. And then there are dreams. Dreams are like the beta testing ground for your sense of time. When you fall asleep, your connection to the external world loosens. The clocks on your walls and in your phone keep going, but your brain stops reading them. It goes offline and starts running its own schedule. During REM sleep, the phase where your eyes flick around under your eyelids and your brain lights up like a small city at night, you often experience vivid, story-like dreams. You walk, talk, fly, argue, fall, perform weirdly specific tasks. These dreams have a sense of sequence. They have little plots. Time definitely seems to move inside them. But how does that internal dream time line up with the clock on your nightstand? Lucid dream experiments, where dreamers learn to realize they're dreaming and send signals with pre-agreed eye movements, suggest that, at least sometimes, time in a dream is not too far off from real time. Ask a lucid dreamer to count to 10 in the dream and signal when they're done, and the outside observer sees about 10 seconds pass. Other nights, you wake from a dream that felt like a whole day or a whole life. You visited 3 cities, changed careers twice, had a long argument about jam with your 3rd grade teacher. You check the clock, and you've only been asleep 20 minutes. The explanation, again, seems to be memory. Dreams don't have to play out every moment of the story. They can jump. They can compress. They can imply hours with a single scene. When you remember the dream, you stitch the jumps together into a continuous narrative, and that narrative feels long even if the raw runtime was short. Even inside the dream, your sense of time is built out of content. Busy, emotional dreams feel rich and extended. Fragmented, hazy dreams slip through your fingers as soon as you wake and leave barely any impression. Underneath all of this is another important piece. Your brain's sense of now is not instantaneous. It's a little window. You don't perceive each exact millisecond as a separate bead on a string. Your brain gathers a small chunk of incoming information, sounds, sights, touch, and glues it together into a single moment of awareness. That window might be a few tenths of a second wide. It's called the specious present, which is a very fancy way of saying the little blob of time that feels like right now. Because the brain needs a bit of time to collect and process data before presenting it to consciousness, your experience now is always slightly in the past. Not by much, a couple hundred milliseconds, just enough that you will never, ever experience the exact instant something happens. By the time you're aware of it, it's already gone. To keep you from noticing this delay, your brain also quietly rearranges a little. It synchronizes signals that arrive at different speeds. A sound takes longer to reach your ears than a light does to reach your eyes. But when you watch someone speak, You hear their voice as if it matched their lip movements perfectly. Part of that is your brain delaying and aligning signals. From inside your own mind, you feel like you're riding along with reality, moment by moment. From the outside, you're like a news broadcast on a short delay, plus a slightly overeager editor doing live corrections. All of that clever machinery has one job: to give a coherent sense of what's happening and what it means for you. It does not care to be a faithful reporter of absolute time. If something needs to be stretched, squashed, backdated, or smoothed over to keep your experience stable and useful, it will do that without asking permission. And this, really, is the theme. Your time and the universe's time are not the same thing. The universe has proper time along world lines, intervals measured by clocks in different gravitational fields and states of motion. It has cosmic time linked to expansion and cooling since the Big Bang. It has quantum parameter time, a number in equations that evolves wave functions. All these are real in their various ways. You have a bloodstream full of chemicals that rise and fall on a daily rhythm. You have circuits that mark short intervals, loops of neurons that predict patterns, a memory system that compresses some events and highlights others, and a consciousness that knits it all into a story with a past you can recall and a future you can imagine. You live at the intersection of those two kinds of time. When you say, "It's late, I should sleep," you're talking about several layers at once. The clock on the wall has reached a certain number. Your internal day-night system is nudging your eyelids heavier. Your memory of the day is full enough that it feels complete. Your expectations about tomorrow are starting to spool up in the background. None of that is wrong or fake because it doesn't match some cosmic clock. It's just one more example of time being local and personal. We've already seen how physics refuses to give us a universal now. There's no one slice through space-time that everyone can agree on as this moment. Black holes and distant galaxies and expanding voids all disagree. Proper time is always for this observer along this path. Your brain takes that already relative situation and adds another layer of relativity. This is how long it felt. Minutes and hours turn into elastic bands. If you zoom out far enough, that's kind of beautiful. You're a tiny piece of a universe that has grown complicated enough to not only be carried along by time, but to feel it, argue with it, resent it, savor it. To say, "That was too short," or "I hope this never ends," even though both are just arrangements of change. So when you wonder if the universe knows what time it is, remember that part of the universe, this squishy, sleepy human part, definitely does. Not in the language of billion-year expansions or gravitational potentials, but in the language of yawns and 5 more minutes, and the way a perfect moment with someone you love can feel like both a second and a lifetime. The universe doesn't label those moments. It doesn't set them aside, but you do. Inside your own little patch of space-time, your brain is constantly bending the raw physics of time into something that feels like a life. Your brain is clearly doing acrobatics with time, stretching it, compressing it, quietly editing it so the world feels smooth and continuous. Once you notice that, another question sneaks in through the side door. If time feels so different inside a mind, what does it feel like outside one? Take something simple enough that it can't possibly have an opinion about time. Take the moon. You look up, you see that pale disk hanging there, and instantly your brain adds a caption. Night, late, maybe calm, maybe lonely, maybe romantic, depending on your personal playlist. The moon becomes a symbol, a mood, a clock face in the sky. But the moon has no idea it's night. There's no awareness in it. No neurons, no dreams, no "I'm tired." It doesn't know about your day. It doesn't know about your calendar. It doesn't even know it's a moon. It's just a big lump of rock following simple rules. Move according to gravity, reflect sunlight, mind your own business. Half of its surface is lit at any given moment. Half is dark. That's true when you're awake, when you're asleep, when no one on Earth is looking up. The phases you see, crescent, half, full, are just geometry, angles between sun, Earth, and Moon. Nothing about them says this is Tuesday or it's past your bedtime. Those labels all live in your head. That's the first big divide to sit with. The universe has patterns, but it doesn't have meanings. You supply those. Night is a pattern. Your part of Earth rotates away from the sun. The ground cools, the light dims. Your nervous system and hormones are tuned to that change, so your body says, this pattern again. Time to wind down. But that's a local loop, a small feedback system. The cosmos doesn't clap when it's midnight. It doesn't pause when you sleep. You can almost feel the mismatch when you check the time right now. Somewhere on your phone or your wall, there's a neat digital or analog answer, a specific hour and minute. To you, that number carries a lot. Maybe it means I should already be asleep, or this is my favorite time to stay up and think. It comes wrapped in habits, guilt, comfort, whatever your brain has attached to it. To the moon, that same moment is just one more tiny change in angle along its orbit. To the atoms in your pillow, it's just one more tiny shuffle in their vibrations. They're not syncing up to your schedule. Your schedule is syncing up to them. It's tempting to think of the parts of the universe that seem to track time, clocks, rotating planets, beating hearts, as evidence that time is built into everything as a kind of internal awareness. But those are just systems with periodic behavior, loops that repeat and can be counted. A pendulum swinging, a quartz crystal vibrating under an electric field, an atom flipping between energy levels, the Earth turning. None of these knows anything. They just do what their structure lets them do. Repeat. You watch those repeats and decide they're useful. You mark each swing, each vibration, each sunrise, and carve reality into little chunks. Seconds, minutes, days. Over centuries, you refine and standardize those chunks until the whole planet can say, let's meet at 7 p.m. and roughly succeed. That shared agreement is powerful. Civilization level powerful. Planes land, markets open, live streams start, alarms go off, all because a network of human-made clocks stick to the same pattern. But the power comes from us, not from the universe whispering, okay everyone, it's 7 o'clock. The moon is the perfect counterexample staring you in the face. You can look at it and instantly know roughly where you are in the night. You can use its phases to track months. You can use its position for navigation if you're old school and heroic. And yet, it is utterly indifferent. If every human vanished tomorrow, the moon's orbit wouldn't change. The tides would keep rising and falling. The nights would keep coming. The pattern would continue, minus the beings who called it time. That doesn't mean time would stop existing, only that a particular layer of time, the layer full of labels and meanings, would disappear. It helps to think of time as having at least two levels. At the bottom is structural time. This is the one we've been talking about in physics. Space-time geometry, world lines, proper time, quantum evolution, entropy increasing. It's the raw order of events, the way one state grows out of another. This layer is there whether anyone sees it or not. Stars collapse when they run out of fuel whether or not anyone is around to name the day. On top of that is experience time. This is the one you live in. Seconds that feel long or short. Nights that feel heavy or light. Years that blur or expand, depending on how much you've packed into them. This layer only exists where there are observers, brains, sensors, any systems that can form records and assign meaning. The universe absolutely has the bottom layer everywhere. The top layer is patchy. It bubbles up in certain places. Earth, maybe other planets, if we get lucky with life. Maybe machines, someday, that keep their own timelines in a more literal way. The phrase, does the universe know what time it is really smuggling those two layers together. We're asking if the bottom layer acts like the top layer. Does the cosmos experience its own history? Does it keep a diary? Does it feel transition? The moon says no, or rather, it says nothing, which is the same thing. But then quantum mechanics shows up behind it and clears its throat. Down at the particle level, you do get something that looks a tiny bit like attention, although that's probably too dramatic a word. What you get is measurement and interaction. A particle's fuzzy state becomes definite when it interacts in the right way with something else. That interaction leaves a trace. A new record appears in the world. A photon with a particular energy, an electron in a particular place, a detector that has clicked. Those records are what make objective history possible. Without them, the universe would still have structure, wave functions evolving in parameter time, but there'd be nothing like the hard, crisp skeleton of this happened, then that. In that sense, every interaction acts as a tiny, dumb witness, not in any conscious way. A Geiger counter doesn't know what radiation is. A leaf doesn't know the wind. But when they're nudged, they change, and that change encodes information about what nudged them. Over billions of years, those tiny, dumb witnesses accumulate into big, complicated ones. Eyes and brains, cameras and hard drives, fossils and tree rings. Each adds more records to the pile, making the past more fixed and the future more open. So you get this chain. Bottom layer structural time governs how things can change. Interactions write those changes into the environment as records. Complex systems arise that can read those records and form an internal sense of time. Those systems then begin to care about it. They mark it, organize around it, fear it, love it, complain about how much of it they don't have. The moon is part of structural time. It participates in the gravitational dance. It reflects light. It raises tides. It's been evolving its orbit since it formed. But it doesn't make the jump to caring. It doesn't read any of the records it helps create. You do. You stand under it, or lie under it, in your case, and fold its presence into your story. You remember other nights with the same moon. First kisses, last walks, anxious thoughts, quiet relief. You project all of that onto a rock that has never, not for 1 microsecond, had a feeling. It's a strange kind of partnership. Unconscious universe providing rhythms and constraints. Conscious bits using those rhythms to build lives. There's another angle here. The divisions of time we lean on most, day and night, weekdays and weekends, years and seasons, are tied to cycles in nature. Rotation, orbit, tilt. Those are very physical, structural processes. But the boundaries we care about inside them are pure convention. Midnight, for example, is arbitrary. There is no cosmic gong at midnight. The sun doesn't know when your calendar flips. Noon has a physical counterpart, the sun highest in the sky. But society has quietly rearranged even that. Time zones, daylight savings, all the little tricks we use to make clock time line up with social time. It's a patchwork glued onto the sky. Even your birthday, which feels like a cosmic marker when you're small, is just an anniversary of one orbit of the Earth, plus or minus the fudge factors of leap days and time zones and hospital paperwork. The universe isn't celebrating that day. You and the people around you decide it matters, and then treat it like it does. In that sense, asking if the universe knows what time it is like asking if a river knows what month it is. The river just flows. It rises and falls with the rain. It freezes if it's cold enough. You can say this is April water if you like, but the water doesn't care. What makes that question interesting, instead of just a philosophical shrug, is that a tiny part of the universe does care. A little patch, the human brain, has gone from being pushed around by tides and seasons to building abstract structures on top of them. You wear watches that are more precise than any natural cycle. You plan months ahead, years ahead. You can talk about what might happen a billion years from now, even though you'll be gone, and build models that predict it. You can look back billions of years using telescopes and think, so that's what it was like when everything was young. The universe doesn't need that. It will keep expanding, keep cooling, keep evolving whether anyone graphs it. But the fact you can graph, it means something new exists, a way for the universe to see itself, however dimly. The moon doesn't know it's night, but you do. The galaxy doesn't know it's 13.8 billion years old, but you can work that out. A dying star doesn't know it's in its last phase, but somewhere on a small planet, someone may be watching it and realizing what it means. There's a kind of quiet humility in that. The more you understand about time structurally, the Big Bang, space-time curvature, entropy, quantum jitters, the clearer it becomes that your experience is not central. The universe isn't arranged around your schedule. It's vast, indifferent, and very, very patient. At the same time, the more you notice how your experience is built, the way your brain edits and stitches moments, the way you hang meaning off cycles, the way you feel nostalgia for things that only took a minute, the more you see that this little pocket of awareness is not trivial either. You're not the clock of the universe, but you are a clock of kind. You are a finite, fragile device that marks out a span of structural time and fills it with subjective time. Memory, anticipation, boredom, delight. That's not nothing. If structural time is the scaffolding, experience time is the decoration. The scaffolding doesn't care what you hang on it. The decorations change nothing about whether the building stands. But to the people living inside, the way it feels matters. Back to the moon for a second. Next time you notice it, whether it's sharp and bright or a faint smudge through clouds, you can let both truths sit together. On one hand, it's just a rock orbiting according to gravity. No idea it's lighting up your night walk. No idea it's been inspiring poets and insomniacs and scientists for as long as humans have had necks to crane. On the other hand, it's a marker you've chosen, consciously or not. A quiet signal in the sky that your brain has filed under night, calm, distance, mystery. It has become part of the way you feel time passing, even though its motion would look exactly the same if no one watched. That tension, that gap between the universe's indifference and your experience, is going to be with us until the end of this story. It's where the original question lives. Structurally, the universe doesn't need to know what time it is. It just is what it is at each moment along its world line. Experience time, though, is all about knowing. Knowing that a moment is come and gone, that another is coming, that there are only so many in a human life. You are a tiny patch of matter that woke up inside a huge, ancient process and started asking, where are we on the clock? Even though there might not be a clock in any ultimate sense. The moon, calm, blank, reliable, offers one answer. There's a rhythm, but no awareness. Your heartbeat, your memories, your questions offer the other. There's awareness, but no guarantee of rhythm, just a feeling of passing through something you can't quite define. Somewhere between those answers is the strange truth of what time is for a universe that doesn't need to be awake to keep going, but is in at least one small corner awake enough to wonder. Think of the moon again for a second. That blank, patient rock circling above you, totally unaware that you're calling this moment late or too late or way past when I'm meant to be asleep. It just moves. Now, imagine leaving the Earth entirely, drifting out past the moon, past the satellites, heading into the dark. The clocks down there keep ticking, the notifications keep chiming, but they start to feel like a very local joke. From up here, the whole planet is just a spinning ball of weather and city lights, turning in and out of its own shadow. All those time zones you've built, lines on maps, offsets from an arbitrary Greenwich, are suddenly just stripes of sunlight and darkness sliding across clouds. The hour that means lunchtime in one band means midnight in another, even though the sunlight falling on the atmosphere hasn't changed in any deep way. It's just geometry. The rest is human paperwork. You know this, of course. You've had jet lag. You've flown across an ocean and felt your body stubbornly insist it was morning while the clock insisted it was 3 a.m. in a hotel room where the light switches were all in the wrong place. You've seen how elastic even social time is, how it can be shifted by an airline schedule and a stamp in your passport. But there's a deeper version of that trick waiting once you step away from the planet. Beyond the human time zones, there are cosmic ones. We've already seen pieces of them. A GPS satellite in orbit feels time pass slightly differently than your phone does on the ground. Not feels, really. It isn't feeling anything. But its onboard atomic clock ticks at a slightly different rate because of its speed and its altitude in Earth's gravitational field. Engineers have to correct for that just to make sure your map app doesn't think your bed is 20 kilometers away. That's a time zone of sorts, up here versus down there. Not pulled from a government decree, but from the geometry of space-time. Move further out and the differences grow. An astronaut orbiting high above the Earth lives through a slightly different amount of proper time than you do between the same two events. Stand at sea level, stand on a mountaintop, wait 10 years, and you will not have aged by exactly the same number of nanoseconds. In daily life, those differences are so tiny you can happily ignore them. But they're real, baked into the way the universe works, not optional. Push this further. Picture a clock orbiting near the edge of a black hole, where gravity is intense and space-time is deeply curved. From the clock's own point of view, nothing strange is happening. It ticks steadily, 1 second after another, the way any good clock does. From your point of view, watching from a safe distance, its seconds stretch out. The signals it sends you arrive farther and farther apart. Its ticks fall behind your own. If it tries to send you one last signal as it drifts towards the event horizon, that last tick seems to slow, smear, redshift, and linger, as if time for the clock has almost stopped. Same universe, same general laws, wildly different local rates. You could draw a map of the cosmos where instead of latitude and longitude, each point is labeled with how fast does time run here compared to there. That map will be a patchwork. Near massive clusters, deep wells. In emptier regions, a slightly faster flow. Near black holes, time drawn out like taffy. Everywhere, proper time along each object's path, refusing to be pinned to a single global standard. Back where clocks and calendars were invented, we quietly pretended there was one time for everyone. What time is it? Carries this hidden assumption. There should be one answer. 30 past 8, quarter to 9. Something that fits on a digital display and settles the question. Relativity just grins and says, okay, sure, but you have to say for whom. What time is it? For someone on the International Space Station. For a muon traveling close to the speed of light in a particle accelerator? For a probe skimming past Jupiter? For an alien sitting on a planet orbiting a star in a distant galaxy, whose light is only reaching you now after traveling hundreds of millions of years. For that alien, your now is there long ago. When you look at their star in the night sky, the light that hits your eyes left that system before humans existed. If someone there pointed a telescope at our sun with absurd resolution, the Earth they'd see might be in the age of dinosaurs. There, what's happening right now on Earth would be filled with teeth and ferns. The speed of light is finite. It takes time for information to travel. So when you look out at the universe, you never see it as it is. You see it as it was. Nearby things are only slightly out of date. The farther out you look, the older the image. The night sky is a time machine with no live feed. That alone is enough to ruin the idea of a clean, universal present. You can't draw a simple horizontal line and label everything on it now. One region's now is another's distant past. The universe doesn't organize itself into a neat slideshow where every slide is the same age everywhere. It's more like a tangled stack of photos, each taken at different times, each arriving at different moments. There's a way cosmologists cheat a little. They define something called cosmic time, the time measured by a hypothetical observer who is at rest with respect to the overall expansion of the universe. Imagine someone who sees the cosmic microwave background, the afterglow of the Big Bang, as perfectly smooth in every direction, with no Doppler shifting from their own motion. That person, if they could exist, would carry a kind of standard clock tied to the age of the universe. We say things like the universe is 13.8 billion years old, with that cosmic time in mind. It's a very useful concept. It lets us talk about epochs in a universe's history. When the first atoms formed, when the first stars ignited, when galaxies assembled. But even cosmic time is a choice of perspective. It picks out a particular way of slicing space-time that's convenient for the large-scale structure. Real observers are always a bit messy compared to that ideal. Moving, accelerating, falling into or out of gravitational wells. Their proper times will always differ a little from the cosmic tick. So no matter how you dress it up, you end up having to admit, there is no master clock stamped on the universe. There are many clocks, many time zones, many local rates and rhythms. Physics lets you translate between them. You can work out how much time has passed for the astronaut versus the person on Earth, or for the star near the black hole versus the star far away. But there's no central authority keeping everything in lockstep. And that leads to another flavor of your question. If there's no master clock, is there at least a cosmic schedule? The patterns, sure, make it tempting to think so. Stars form, burn, and die in understandable ways. Galaxies evolve. The universe expands and cools. You could draw a timeline and mark out phases. Early on, hot, dense, smooth, low entropy. Then, first stars, first galaxies, things starting to clump and shine. Later, rich structures, heavy elements, planets, chemistry, life. Later still, stars thinning out, fuel running low, black holes and embers. Much later, the long fade toward heat death, when entropy has done its work and there's not much left to rearrange. Looked at from far enough away, it almost feels like seasons. A cosmic spring, summer, autumn, winter, but the universe isn't working from a to-do list. It never sits there thinking, okay, star formation phase for a few billion years, then we'll pivot to black holes. It's just the natural consequence of the rules. Gas clouds follow gravity and pressure. They collapse if certain thresholds are met. They ignite if they get hot enough. They explode if they run out of fuel in certain mass ranges. Every star's schedule is set by its initial conditions: mass, composition, environment. Small stars burn slowly and live trillions of years. Massive stars burn ferociously and die young. Everywhere, the same laws. Everywhere, different specifics. It's like planting seeds in a wild field. You get a pattern: sprouts, growth, flowers, decay. But no individual plant is running on the same clock as any other. They're all just responding to sunlight, water, and soil in their own local way. The universe's schedule, such as it is just a description after the fact. When scientists say, we're currently in the stelliferous era, the age of stars, they're really saying, given the initial conditions and the rules, this is the part of the story where stars are plentiful and bright. We happen to exist in that bright middle, not in the blinding early flash when atoms barely held together, not in the frozen far future where everything has gone dim, but in the era when there's enough time and energy for complexity to bloom, enough stability for planets to form, for life to evolve, for brains to invent podcasts to fall asleep to. If the universe had a consciousness, this might feel like the late afternoon of its life. The sun's still high, but long shadows starting to hint that the day won't last forever. Thankfully, it doesn't have a consciousness. That's your job. And this is where things circle back, like the moon to its orbit. The universe doesn't need a clock or a schedule because it doesn't need to coordinate anything with anyone. It isn't trying to catch a train. It isn't late for an appointment. It's just running. You, on the other hand, are a being made of limited time. You have, in cosmic terms, the lifespan of a spark. You wake up inside this huge, ancient process, look around, and instantly start building clocks and schedules and plans. Because you need them. You need to know when the seasons change so you can plant, when night falls so you can sleep, how long food lasts before it spoils, how long a journey will take, how much time you have before something important happens, or before it's gone. Your whole nervous system is built around this scarcity. You feel the passage of time not as a neutral coordinate, but as a kind of pressure. There's homework to finish, bills to pay, people to call, shows to watch, things you want to do, and the constant small knowledge that you won't get to all of them. That's why what time is it feels charged in a way, what temperature is it doesn't. It's why midnight feels different than noon, even if you're in a windowless room. It's not just light level, it's story position. From the universe's side, all of that is a local disturbance. A little wave on the big river. It doesn't disrupt the large-scale flow of expansion and cooling and entropy. But from your side, it's everything. It colors every moment. In a way, The universe has countless time zones and no schedule, and you have a very tight schedule inside one tiny time zone. You can use that contrast in two ways. One is to feel small and slightly doomed. Great, the cosmos is chilling out on billion-year cycles, and I'm stressed about tomorrow's meeting. The other is to feel strangely relieved. My stress, my deadlines, my sense of being behind, those are just little ripples in a much larger, calmer thing. The universe isn't mad I didn't finish my to-do list. It doesn't know what a to-do list is. From out there, from moon distance, from galaxy distance, your entire life is a flicker. A single, bright, complicated fluctuation in a patch of space-time that will eventually be as cold and featureless as everywhere else. That might sound bleak, but it also means you are completely free to decide what your flicker means. The universe doesn't hand you a time. It hands you conditions. Gravity, energy, chemistry. It hands you, very briefly, this arrangement of atoms that can feel and think and ask weird questions at odd hours. What you do with that is entirely up to you. When you ask, does the universe know what time it is? Maybe the most honest answer is, it doesn't need to. But you do. And the way you choose to know it, to frame your seconds, your nights, your years, that's part of what turns structural time into a lived life. Right now, you're lying in a small room on a spinning planet, in one narrow band of sunlight and shadow, listening to someone talk about time zones that don't care whether you sleep or not. Somewhere else, sunrise is starting. Somewhere else, someone is staring at the same moon and feeling something completely different. We've wandered from your bedside to the edge of black holes, from your stress about tomorrow's schedule to the universe casually stretching itself across billions of years like it has nothing better to do. We've watched clocks disagree, galaxies lag behind each other, and the moon completely fail to care about what your calendar says. So now there's another question waiting quietly at the edge of all that. What happens to time when the clocks run out? Not just your alarm clock or your watch or your phone. All clocks, all processes, all the little tickers that give you any way to tell before from after. You already know, deep down, that time is glued to change. Even in ordinary life, if nothing changes, time gets slippery. Think about sitting in a waiting room with no phone, no sound, no view, no movement. Just a chair for blank walls, and you. The clock on the wall is covered. What's left to measure anything against? You still have your heartbeat, your breathing, the little micro movements of your body, the drift of thoughts. Your brain will turn even that faint static into some sense of passing. But if you strip it down further in imagination, no heartbeat, no breath, no thoughts, no new sensations, you hit something weird. Without change, you can't tell one moment from another. The same thing happens when we zoom out instead of in. Right now, the universe is busy. Stars burn, planets orbit, gas clouds swirl and collapse. Black holes feed, radiation streams through space. On smaller scales, atoms vibrate, particles decay, quantum fields jitter. Every one of those things is a clock of some kind. Not because they know they're tracking time, but because they provide a regularity or a progression you can, in principle, use as a reference. How many times has this atom vibrated? How much has this star cooled? How far has this galaxy moved? Physics builds a lot of its sense of time out of that kind of bookkeeping. Take a process, look at how it changes, attach a parameter t to that change. Repeat for everything else. You get a mess of local clocks that more or less line up if you correct for gravity and speed. But follow entropy's arrow far enough into the future and the mess starts to thin out. Stars run out of fuel. The bright, stable middle-aged ones like our sun puff up, shed their outer layers, and leave behind white-hot cores that slowly cool in the dark. Massive stars blow themselves apart and collapse into neutron stars or black holes. The reservoir of cold gas that can form fresh stars gets slowly used up or blown away. Galaxies don't last forever as glittering cities of starlight. They burn through their fuel and gradually turn into places full of cinders and darkness. On longer timescales, still, the cinders cool. White dwarfs fade into black dwarfs. Neutron stars may eventually decay. Black holes, according to the best ideas we have, slowly leak energy through Hawking radiation, taking absurdly long to evaporate, but not, as far as we can tell, immortal. In that far-out picture, the universe drifts toward a state people ominously call heat death. It sounds dramatic, like a cosmic explosion, but it's actually the most boring thing imaginable. It's not about heat. It's about uniformity. Right now, the universe has temperature differences everywhere. Hot stars, cold space. Thermal gradients you can use to do work, run engines, drive chemistry, power life. Heat death is what you get when all those gradients have evened out. When energy is so spread out and so uniform that nothing useful can be done with it. No hot here, cold there. Just lukewarm everywhere, forever. Entropy maxed out. In a universe like that, most of the clocks we rely on simply stop working. Stars aren't shining. Radioactive elements are gone. Orbits have decayed or become meaningless in the thin fog of matter. There are no cycles to track, no slowly burning fires, no stable structures undergoing interesting transitions. You could, in principle, still define a coordinate called t in your equations and let it run off to absurd values. T equals 10 to the power of whatever. But what would the difference be between T1 and T2 if nothing at all changes? Without clocks, without events, without new records, time becomes like an empty ruler in a universe with nothing to measure. You can hold it up, you can say this side is 1 meter from that side. But if there's nothing to place along it, the measurement stops having teeth. There are two ways physicists and philosophers tend to talk about this. One way says, time is a fundamental dimension. It exists regardless of whether anything is happening. Even in a completely static universe, time passes in the sense that the coordinate increases. It's just that nothing is there to notice, and there are no processes to use as clocks. In that picture, the heat-death universe still has time. It just doesn't have stories. The other way says, time isn't really separate from events. It's not this extra backdrop you can peel away from what happens. It's a way of describing change itself. If nothing changes, there is no before and after, and so saying time is passing is like saying motion is happening in a world where nothing ever moves. In that picture, the end of interesting change and the end of useful time are the same thing. It's a bit like asking, does music still exist in a forever silent world? You can argue yes. Music exists as a concept, as a space of possibilities. Or you can argue no. Without sound, the word stops referring to anything real. With time and heat death, you're in that same gray zone. Either way, something is lost. Right now, every second in the universe is packed with transformations. Particles colliding, fields interacting, photons flying, matter falling, life thinking. There's a rich tapestry of before and after being woven everywhere, most of it unnoticed by anybody, but still there. In the heat-death limit, the tapestry stops growing patterns. It just stretches out into a slowly thinning blur. If you could somehow be in that future and ask, what time is it? The technically correct answer might be very late. But the meaningful follow-up question, late compared to what, would have no answer. There'd be nothing left to compare. Even the idea of entropy increasing, the thing that gave time its arrow in the first place, would have run out of road. Entropy can increase past its maximum. Once everything is as disordered, as spread out, as probable as it can possibly get, the arrow loses its direction. It's like rolling downhill and finally reaching the flat plane at the bottom. You can walk around, but there's no more down. In that sense, the end of time isn't a dramatic cosmic clock hitting midnight and freezing everything in place. It's more like the fading of time's direction, the soft erasing of any difference between one moment and the next. It's weirdly similar to something much closer to you, deep, dreamless sleep. When you fall deeply asleep and don't remember your dreams, your conscious sense of time drops out. You close your eyes, there's a gap, and then suddenly it's morning. 8 hours have passed, but to your awareness, it's been a jump cut. The clock by your bed has moved. Your body has done a mountain of maintenance, repairs, sorting, cleaning, rebalancing. But your experience time has collapsed into a single blink. Heat death is like that at the cosmic level, except the morning never comes. The jump cut just keeps going. No more structure builds. No new experiences or stories pop up. If there are any clocks left, they're counting something that never varies. And what about quantum time, that jittery underlayer? Even that starts to look thin. Quantum fields still exist in the heat death picture. They still have vacuum fluctuations, tiny temporary excitations. But if there are no stable structures to record those jitters, no systems to store information about them, they remain pure noise, like static with no receiver. Remember earlier when we talked about records? Those little entropic knots where the universe has written this happened. In the far future, almost all of those knots would have been smoothed out. Black holes, which might have hoarded information about everything that fell in, will have radiated away. Other remnants will have decayed. The details of the past, encoded in structure, will have been blurred past retrieval. The past itself doesn't vanish. The fact that it happened remains, but the universe's ability to hold onto the specifics erodes. You, lying in your room right now, are surrounded by records. The arrangement of furniture, the scratches on the floor, the text threads and photos on your phone, the patterns of connection in your brain that store every memory that matters to you. All of those are improbably ordered configurations tracing back through an entire chain of causes. You're living in a rare era of the universe where those chains can still form and survive for a while. Where clocks, diaries, fossils, hard drives, neurons, all the ways of saying once it was like this are possible. Later, those possibilities shrink. The capacity to remember, to store, to differentiate fades. Not because the universe hates memory, just because the odds favor spread out uniformity. The same probabilistic slope that pushes cream into coffee pushes patterns into noise. So a universe without clocks isn't just a cute mental picture. It's an actual limit state we think the cosmos might be heading toward, a place where no new clocks can be built and old ones have all been dismantled by time itself. What does that say about the moment you're in? Maybe it highlights how strangely precious it is. This is a universe with clocks, with rich, overlapping timescales. The quick flicker of atomic transitions, the slow burn of stars, the orbital loops of planets, the ticking of hearts, the back and forth of messages, the growth of forests, the evolution of species, the rise and fall of civilizations. And nestled in there, the small, personal time you inhabit, the span of years where you get to be aware that any of this is happening. The universe has already used almost 14 billion of its cosmic years to get here. To move from a hot, smooth soup to a place with galaxies and heavy elements, and at least one planet where beings sit up late, asking if the universe knows what time it is. Compared to the vast future, all of this, everything you can see in the night sky, every star you can name, every story anyone has ever told, is part of a single brief phase. The clocked phase, the era where time not only exists structurally, but is busy, uneven, creative, wonderfully inefficient. You're not late to that phase. You're right in the middle of it, living through one of its ordinary but astonishingly rare seconds. You can't do anything about what happens trillions of years from now. By then, heat death or big rip or some other exotic ending will have played its cards. Time will either be a meaningless coordinate or something so different it barely deserves the same name. But you can do something about what happens in the very small slice where you actually are. You can choose to treat the seconds you have not as generic units on a cosmic spreadsheet, but as moments that can be thick or thin depending on how you fill them. You can notice that right now, unlike in the far future, there's still change, still contrast, still warmth moving from place to place. Still time in the sense that matters to living things, a field for actions and choices. That doesn't mean you have to be productive all the time. Honestly, no. Sometimes the best thing you can do with your limited, precious, structured time is exactly what you're doing. Lying still, breathing, letting your awareness wander through big questions that don't demand immediate answers. A clockless universe doesn't ask questions. It doesn't pace. It doesn't worry about being early or late. It's the final extreme of whatever happens, happens, and eventually nothing does. You, for the moment, are something else, a self-aware interruption in that drift, a little pocket where time is sharp enough to feel and soft enough to be shaped. When you ask what time is in a universe without clocks, the honest response is probably just silence. When you ask what time is for you, right now, in this quiet room, the answer is louder, even if you don't put it into words. It's in your pulse, your memories, the weight of your eyelids, the tug between wanting to stay up with the mystery and wanting to slide into sleep. And behind that personal answer, all the physics we've walked through is just background scenery. Useful, beautiful, humbling, but still scenery. The clocks will eventually run down. The universe will one day forget how to tick. But tonight, it hasn't yet. Tonight, you are here in one small, luminous corner of a still-clocked cosmos, asking questions that only make sense in a universe where things can begin and end. So here you are, at the end of this long wandering through clocks and stars and dreams and quantum jitters, and somehow you're still in the same place you started. A room, a body, a breath, a moment called now. We've taken time apart from a lot of angles. We've watched it bend near black holes, jitter in quantum experiments, stretch in your memories, dissolve at the edge of heat death. We've watched the moon ignore your bedtime and GPS satellites argue about seconds. We've watched the universe sprint through its first second and then relax into billions of years of cooling and clumping and glowing and thinking. So after all that, back to the original, almost childlike question, does the universe know what time it is? The short answer, if you want one, is no. There is no cosmic wristwatch. No central server humming away somewhere, broadcasting the one true time to every galaxy. No grand consciousness saying, yes, it's precisely 13.8 billion and some change since the Big Bang. We should really be moving on to the next phase. The universe doesn't know it's young, or middle-aged, or old. It doesn't know this is your night and not someone else's morning. It doesn't know this second from the one before or the one after. It just is what it is at each point along whatever path it happens to be on. And yet, under that simple no, there's a quieter, more interesting kind of yes hiding. Because while the universe doesn't know time in the way you do, it absolutely keeps track of order. The equations of physics don't carry little labels like Tuesday, but they do carry structure. What can lead to what follows from what, which states can come next, and which ones are gone for good. Entropy gives that order a direction. Quantum records give a spine. Spacetime geometry gives it shape. Proper time ties it to each path. All those pieces together mean the universe doesn't just exist as a static picture. It exists as a network of before and after, even if it doesn't sit back and reflect on them. That's one sense in which it knows time, not as a number on a clock, but as a consistent pattern of change. Then there's you. You're made of that pattern. You're built from atoms that formed in stars that burned according to those rules. You sit in a little gravity well on a rotating planet, with blood moving through vessels and ions zipping across neuron membranes, all following the same underlying physics as collapsing galaxies and boiling plasma. Out of that, somehow, comes something new, a sense of time from the inside. You remember, you anticipate, you worry about being late, or feel relief at being early, or look back at whole years and say, that went fast, or that was the longest year of my life. You feel some moments as light and some as heavy. You replay certain days so often in your head that they seem to stretch across decades. That internal landscape doesn't exist in equations. It's built out of them, but it's not in them. It's something the universe only gets when it happens to arrange matter into beings who can carry memories and stories and questions. If the universe ever knows what time it is, it knows it as you. It knows it as the part of itself that can say, "It's late and I really should sleep," or "I wish this night would last forever," or "I can't believe it's already been 10 years. It knows it as the part of itself that lies here listening to someone talk softly about entropy and early universes and the first second after the Big Bang, and feels all of that, somehow, as a single, continuous experience. Remember that thought back near the beginning about the universe being like a stage with no need for actors? Space as a floor, time as a dimension, physics as the rules. You don't have to invite anyone on. The show can just be empty scenery forever. And yet, the stage didn't stay empty. For at least a tiny stretch of its runtime, the universe has actors, stars, planets, bacteria, trees, cats who very much believe time is now, and also food and humans who can lie awake and ask whether any of this makes sense. You're a little moving light on that vast, dim stage, carrying your own small clock and your own peculiar idea of what matters. Your existence doesn't change the laws, but it changes the view. You give the universe a way to look at its own history and say, "That's a beginning, that's a middle, that's an end. That moment was important to me." The universe doesn't need that in any survival sense. It will be fine without your narratives. But the existence of those narratives makes something true that wasn't true before. There's at least one vantage point from which this whole sweeping, indifferent process feels like a story. Does the universe know what time it is when a star collapses? No, a star doesn't know it's dying. It just runs out of fuel and follows its own gravity. Does it know what time it is when a child blows out candles, when someone falls in love, when someone says goodbye for the last time? Structurally, those are just events, configurations of atoms and energy. Nothing flashes in space-time saying, "Special moment here." But in the minds that live them, those instants become anchor points. Before this and after this. Whole lives orbit those little personal singularities. Those orbits are every bit as real, in their own local way, as the moon's path or a planet's year. They're built on the same fabric, space-time and energy and entropy. They just add meanings that physics doesn't bother to track. You can feel 2 layers of time right now, if you pay attention. There's the slow, steady bottom layer, your lungs filling and emptying, molecules trading energy, the Earth rotating you imperceptibly a few hundred meters east as we talk. All of that would keep happening if you weren't paying attention. Then there's the top layer. We're near the end of this story. You can sense it, the way the ideas have looped back around. The tone shifting from explanation towards something softer. The quiet mood of late-night reflection settling in. Those 2 layers are woven together, but not identical. The universe owns the bottom one. You own the top one. And maybe that's the quiet answer to the question. The universe doesn't know what time it is in the way your phone does. It doesn't have a single share now. It doesn't care about deadlines or anniversaries. It has structure and history, but no hurry. It can't be late. It can't run out of time in the way a human day runs out of hours. You, on the other hand, know time far too well. You know that you can't stop it, that there are only so many mornings you'll get, only so many times you'll see the moon, only so many nights like this one where you're awake enough to wonder about any of it. And because you know that, you have something the universe as a whole never will. The ability to choose how to spend a moment. To turn it into stress, or into gratitude, or into curiosity, or into rest. Tonight, you've spent it on a strange little journey through relativity, quantum mechanics, cosmology, neuroscience, philosophy, just to circle back to your own breathing. You started with a question about the universe. You ended up, as you sort of had to, with yourself. The universe may not know what time it is, but you do. You know that this is one more night in the middle of a finite life, in the middle of a brief, bright era of a cooling universe. And that for the next few minutes, at least, there is nothing you have to do except lie there and exist. Whatever else time is, that's not a bad way for it to be used. So now, Let everything we've talked about drift to the edges a little, like a picture being slowly dimmed until only the gentlest shapes remain. You don't need equations anymore, or big words, or distant galaxies. You don't even need the question. You've carried it far enough for one night. Let the idea of time shrink back down from billions of years to something very small and manageable, just the space of one breath in and one breath out. Feel how that tiny stretch is somehow enough to hold all of you. Your weight on the bed, the soft pull of gravity, the faint background hum of whatever's in your room, the way your chest rises and falls without you having to ask it to. You're still inside the same universe we've been talking about, but you don't have to hold it all in your head. It can go back to being big and distant and taken care of. The stars will keep doing their thing. The moon will keep circling, blissfully unaware. Time, in all its strange layers, will keep unfolding, with or without your supervision. All that really matters right now is that you are safe enough to rest. The doors are closed, the day is over, or close enough, and nothing out there needs your attention more than your own tired mind does. If thoughts still buzz, that's okay. Let them buzz like faraway traffic, there, but not important, fading gradually as you stop listening quite so hard. You don't have to force sleep. You don't have to chase it. Just lie there in this one small, quiet moment and let the seconds blur until they stop feeling like little units to be counted and start feeling more like a soft, continuous drift. If you stay awake a bit longer, that's fine. If you slip under mid-sentence, that's fine too. Time will be here when you wake. For now, you can let it hold you instead of the other way around.